This conference will now be recorded.
Hello everyone, welcome to our day 31 in our GCP Cloud Architect training. So last week we finished with data fusion demo. So the reason why it did not work was, I guess you would have seen the recording, the last few 10 minutes clipping. If the recording, if you see, you'll come to know. So the reason why this kind of stuff did not work for us. So we had a storage bucket, we had a Wrangler, and we had a BigQuery as a sink. So why it did not work for us, it was not even throwing any error, was basically I did not see the full log. And when I looked into the full log, or the complete log, I understood that the machine type of the Dataproc instance was not sufficient. So I had to slightly increase it. So I increased it with the limitations which we have in the free trial. So I made it as 2 vCPU for the master, 2 vCPU for the worker node. So totally 6 vCPUs we can use, and then the stuff started working. So you can look into the last 10 minutes recording in day 30, you will come to know. So which basically proved that you have to have better compute option. And the key part with data fusion is everything is user driven. You are not going to write a single line of code. Everything is UI based. So could be really helpful for cloud architects who don't write code. So that's the reason I did this demo. So I'm not sure how much it's going to come in the exam, but would be really helpful during your real implementation. So, and behind the scene, currently data fusion uses Dataproc, and we had seen whenever you run a new job, it creates a Dataproc instance, and once the job is finished, the Dataproc is going to automatically get deprovisioned. And Dataproc and the kind of job it uses behind the scene is scoop job, Hadoop scoop jobs. So that's what we had seen. So today what we are going to see, we had seen the pricing. Today we'll see a demonstration of DataPrep. So last week I had explained DataPrep is from a third party technology partner called as Trifacta. So it's not a Google product. And in the exam, right, you may get some possibilities like looking for anomalies. You want to find anomalies. What do you mean by anomalies? In simple terms, at least in this context, is you have some data, there are some mismatch values. Maybe the data type is integer, but you have a data which is a variable, a string, or an alphanumeric character. Or you may have, say for example, something like duplicate values. You may have some outliers. So usually if the value should be in a specific range, you have something totally out of that range. That's an outlier. So these are all going to be anomalies. Now to find these anomalies, data engineers and data scientists can do via Python program. So they are well versed with it, they do it. But if you were to quickly find anomalies in a data set without much effort put, you can use products like DataPrep. So possibilities of getting a question on this is little high. Even in my recertification, I had got it. So if you see words like anomalies, detect anomalies, anomalies quickly. So the word quickly is the important thing. I'll show you how quickly you can find it. You'll be really amazed by the feature which DataPrep gives, uh, like mismatch values, missing values, duplicates, outliers. These are all the one which is going to really help you to find it using a 3P product, third party product called as Cloud Data Prep. So how, I'll show you. We have the data already, so you can just load the data and you can see it. And this is how the user interface looks like. You just load the data, it's going to show up things automatically without you writing a single line of code. But now what we are going to do is we are going to do the same thing. So this is a screenshot. I had kept it as a backup if for some reason the data prep does not work. So in the beginning days, data prep was provided free of cost. Now it is little expensive. Sometimes people say it is more expensive than data fusion. Um, so better have a screenshot is what I kept. So if you have a data like this, you can visualize a particular column, or sometimes people call in machine learning world, they call it as a feature. So each row is each column is going to be called as one feature. So here you are exploring a column called as department, where you see the top values, mismatched values, outliers, and any other statistics. So let's see this in action by doing a small demonstration. And I had mentioned this in the last class itself. Not every customer is going to go with data prep. The reason is because it's a third party. So you may be comfortable with sharing the data with Google because your legal team would have vetted you, in the sense the customer's legal team would have vetted it. Yes, we don't have any issues with Google Cloud Platform. We can use it. But when you use a third party product, you have to again do a vetting process, like, okay, where they keep their data internally, in which data center, does it leave our country, all those kinds of compliance issues may come. So because of which not every customer would be comfortable. Um, and you have to make sure you ask this explicitly. You have to ask them explicitly, customer, whether you're okay to use data prep. Why? You'll understand it in the next few minutes, because when you activate the data prep service for the first time, it's going to ask you at least 3 to 4 questions, which for us as an individual we can just give yes, 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 or allow. But as an organization, it's going to be really important. So what are those things? Let me show you. So if I go to my big data section, you see the last one, data prep. My understanding is in future this may be removed from big data category and it would be moved to partner solutions. There are other partner solutions, MongoDB, uh, Raiders, all those things. So it may come to this section, is my understanding, because it's going to be not a GCP product, it's going to be a third party product. So, but you get one single invoice. In future, it may happen. It's just my understanding. I may be wrong here. So let me click on data prep. Now, what's going to happen is in next few minutes, it's going to ask basically certain questions. These questions, for our demonstration, we can just agree and continue. But customer in real world, they have to agree to this. The first thing is share account information with Trifactor, meaning you're going to share your account details. So in this case, this account details, like how if you install an app on your phone, you have to allow certain stuffs, right? Should it have access to your contacts, read SMS, all those things, something very similar. So this is between Google and Trifacta. So you have to make sure, yes, I agree and I want to continue. Only if you do this you can access data prep, otherwise you cannot access it. So this is the first screen, folks, and you'll see n number of such screens till we reach the main data prep screen. Agree, and our owner can only do that, project owner. Now the next information, allow Trifacta to access your project data. So this is another information which you have to share. You have to say yes, I want to allow it, otherwise you will not be able to access this service. So basically this is a SaaS offering, folks. Data prep is a SaaS offering, so it's nothing like you would say it is regional or multi-regional. It's a SaaS offering. So click on all, allow, sorry. Now when I do all those things, what's going to happen is it's going to take me to a data prep website, folks. It may look very similar, but keep an eye on the URL. It's going to change to something called as DataPrep or cloud.dataprep, something of that sort. You see that, folks. So this is very important. So our console is always going to be console.cloud.google.com, but look at the URL, folks. Dataprep.com. So now you get two offerings. For our learning purpose, we can use a 30-day trial, and no credit card required. You can use it. Invite others also to use, basically your colleagues or something, or to the customer, you can share it and they can use. So that's the first thing. So this feature was not there. So previously it was totally free. It was totally free. Basically behind the scene, it uses some of the GCP resources. So that way Google was making revenue out of it. But now Trifacta is also making a revenue out of it by having a model, a pricing model. So 30 days, our demo is going to work. Afterwards, it's not going to work. If you want to use completely this, you have an option called as the marketplace. What are the options? You can look into it. I thought it's going to open it in a new tab, but I'll show you the pricing details just to show you. I have to do the details. Okay, fine, got it. So because it's going to be at the end, one single invoice, you are going to get it from Google. So you can see the pricing. So this is the stuff which you get, folks. So in a month, in a year, so per month, based on what you want, if you want a starter edition or a professional edition. So starter edition is going to be around, it's in INR, folks. So because I use an Indian credit card, so it's 37,000. So little expensive when you use this, but it comes with a value add. So you can really compare this with data fusion because you are not going to write a code. Now instead of hiring a person to write uh, a code in Python, Java, you use a service. Basically that is how you can justify the cost, basically. So I'm not going to activate this. What I'm going to do is close this, go back, click on data prep. Hope I can start my free trial. Yes, good. So click on start free trial. So this is the first time setup. So what happens basically is it is also going to have a staging environment. You really now see the value of Google Cloud Storage. Everywhere it comes automatically. So it needs a storage location. By default, it's going to be always data prep hyphen staging. If you want, you can change it. I'm going to leave it as default, which is going to create a storage bucket. So click on continue. This is going to be used for staging purpose. And this is a SaaS offering. By the time it comes, let me just add this in our cheat sheet, data prep. Preparing the data basically. So I'm just going to add a comment as SaaS offering, software as a service. It's a SaaS offering. Okay, there's some maintenance which they are saying upcoming maintenance window for all users. Some stuff which they are going to do. Okay, you see this pop-up. Okay, now I'll close all these pop-ups, folks. Now this is the screen which you see. Now even from this screen, you may get a question, folks. I have seen it. Basically, the source. So if you see here, these are the options which you can use to get your data into data prep. So it's going to be basically, these are the only sources which you have for your data prep. Either you upload it from your local system or upload it from a Google Cloud Storage bucket, Google Sheets is newly added, and BigQuery. Now, if you say I want to read it from AWS S3 bucket, not possible. Not possible unless you do something extra. Maybe if there is a data in S3 bucket, use your transfer service, which we had seen in our storage stuff, from transfer service for cloud. Copy your data or move your data from AWS S3 bucket to a Google Cloud Storage bucket. From your Google Cloud Storage bucket, use all your stuffs for your data prep. So the data should be here. You do something to bring the data to this three of these into these options, then only you do it. So the possible sources. So meaning if there's any other data source which is asked in the exam, you can directly say it is not a good choice. It may not be a possible choice. So, and upload option will definitely have a limitation. How much data you can upload? Not a very huge amount of data. So, and because this is a SaaS offering, they're not going to give you any REST API or command line equivalent. You have to upload it. Now, can I upload 30 gigs? May not be possible because the browser is going to froze when you upload it. Maybe for a short 10 MB, 20 MB kind of data, it's going to work. So if you have 30 gigs of data, it's always preferred to put it in Google Cloud Storage bucket, then do your transformation. So I'm just going to add this in the cheat sheet, the possible sources, uh, possible data source for data prep are. So these are the possible sources. So even questions on this can come. So that's the reason I added this. What happened? Oh, sorry, I'm in a wrong place. My bad. Sorry, folks. So I added the things in a wrong place. I guess we had lots of others comments. Okay. It's our 59th, 60th comment. This is the one. Possible data sources for data prep. So I remember a question related to this. Not the exact question, but this was related to basically you being aware of what is a possible sources which you can have. That's one thing. So let's go back. What I will do is I will use the data which is in our Google Drive. So you can just go to your module 6 data prep. Dataprep.csv is the file which you can use, and I have already downloaded to my local system, which looks like this. The same data is what we had uploaded to Google Cloud Storage bucket for our data fusion demonstration. It's the same data set. So tab separated, some sales data related to some t-shirts orders. So what I will do is I will not load it to Google Cloud Storage, but rather I will use my upload option. I'll use my upload option. So upload, or I have to choose click. So I'll choose my dataprep.csv. That's it, folks. You just need to do only this. The remaining magic automatically happens. At least finding those anomalies, it's going to do that so beautifully. So let's just wait for a couple of minutes. Preview, it shows the preview. If you want to see how the data looks like in the system, it shows the preview. Now click on continue. Just loaded. Click on continue. Is it really working? Yeah. And they keep changing the user interface every time I do my this thing. So that's it, folks. Now you see the same screenshot which you saw here also. Now you may ask, what's a big deal in the screen? So the big deal in the screen is without you doing a single task, you just loaded it, it automatically has analyzed the data. Somewhat similar, I would say Data Fusion would have got some ideas, sorry, from DataPrep. So if you see, last week we had mentioned how the products were launched. First was Dataproc, Dataflow, DataPrep. Lastly was the one which came in Data Fusion. So we remember seeing something very similar screen where you have to load the data into Google Cloud Storage bucket, do some little of create some recipes or transformation to get a UI or a output like this in your Data Fusion. But in Data Prep, you just loaded it. It automatically identified everything and it gives you a statistics about your data set. Now, what are the few statistics which you could be interested in? So the green stuff, if you see, right, it indicates all good. But when you see something like reddish or black, you will see some missing values, 44 mismatched values. User ID, perfect. All values are good. Now let's explore more on this data set. So click on this table or column, sorry. Click on column details. And this is the same screenshot. I had it in the slide also. So same data set, everything is same. Now, what are the anomalies it has found? So basically, this department is a 2-digit numerical. So that's what it understands based on the data. So this is the product's understanding. So top values are 75. So the best department which is working very well is with the department ID 75. Now it has found out some mismatch values. Some of the mismatch values are there are 2B, which is an alphanumeric character, 2A, again an alphanumeric character, mismatch value. So this is the first anomaly which it has found automatically without you writing a single line of code. The second anomaly which it has found is basically outliers. So why it is an outlier? It's a 3-digit number. So the system has identified most of the data set in the department is 2-digit. Now there are couple of or 4 entries which is having 3-digit number. So outliers. So basically an outstanding person. So if everybody does something in one fashion, another person, there could be some outstanding people, right? They do things totally differently. So outliers, those are outliers. That's what it indicates. Now these two things, if you were to do it in program, you have to write definitely a good amount of code. But using the SaaS offering, you don't even write a single line of code. That's a beautiful thing. So that's quick analysis which you get, and also it shows you the pattern, all those things, 3-digit number, 2-digit number, uppercase, all those things. Histogram, how the data is distributed, is it uniformly distributed or something? All those details it gives based on the small data set which we have. Similarly, you see date, maybe if I explore this. Now, there are certain dates, time date did not match the format. So most of the entries are in a proper time format, but there's one entry which is not in this format. Okay, so it is expecting basically the format in YY, MM, DD format. There is one date which is totally in a different format. So different format. So that's what it indicates. So quickly to find out those things. Now what we'll do is we'll try to do some transformation, folks. Like how we did in our data fusion, we do the same thing here. So I will take the example of department. We also played around the department column only last in data fusion. Let's do the same thing. So first and the foremost thing, because this is a French data, I am not comfortable with the French data. I'm going to change the name to department. I'm going to remove this E. So click on rename. So this is one transformation. So rename it to department. Done. That's my first recipe. They don't call it as transformation. They call it as recipe. So good. The second transformation which I'm going to do is maybe, and there are some missing values here. It is empty. So what I will do is maybe I can do something like the same thing, filter rows. So remove columns if the value is missing. filter rows or remove. I have to use replace, or if you want to replace it with a value, you can put it. So if, for example, if it's missing, you enter a value, something like a standard department, you can do that. Or you want to remove it, you can remove. Lots of options are there. Let me just put a custom value. So meaning the first two rows should have some value there. So I'm going to make a department as 99. You see this, folks? This is what it entry is going to show. This is the old column. The transformed column is going to look like this. So, or you want to have 0 0, you can have it. So this is how uh, this is how this transformation is going to work. So I'm going to make it as 99. Done. So this is my second recipe. Basically, it's like more like cooking. So you have multiple recipes doing here. So done. The next part is, now I see that missing value is uh, fixed. Mismatched values. What is that mismatched value? So if I again explore it, the reason why it is showing mismatch value is 2B, 2A is there. So maybe to fix this, there are two options. Either, if I close this, either you remove all the entries which is having a mismatch values, or look at this data type, folks. It is treating itself. We did not get this mismatch either in our data fusion, because in data fusion, every column was treated as string. Every column was treated as string. Now here, looking at the data, data prep has realized that maybe department is a string. Now, instead of making it as a string, if I make it as a, sorry, instead of integer, if I make it as a string, this error could be fixed. This error or this issue could be fixed. So what I'll do is change the data type itself from integer to string. Done. Now it is 100% good. So there's no issue here. Now if I click on the recipes, there's a shortcut to see the recipe, or it should be here. I usually forget that syntax. Where do I see the recipe? Yeah, recipe R. R is the button which I have to click. So totally you have done 3 recipes, folks. One, change the department, replace missing value with a standard value, and you have changed the data type of department to string. Now, if you were to do this, and now what you have done is on a sample data. Now, if you want to do it on a complete data set, which is going to have 29,000 rows, what you're going to do basically is you're going to click on run job. When you click on this run job, what happens behind the scene is the highlight. The part is behind the scene, it creates a data flow job. So you don't need to write a Java code or a Python code. It generates the code for you and you can do it. But the drawback of this data prep is it only supports batch jobs, not streaming jobs. So if it's a batch job, you were to quickly do something on this on data transformation, you can use data prep quickly to do it. So to show you, it creates a data flow job. I will go to my data flow. You will see some of the jobs which you ran previously. So currently it only has nothing. There's no job running. So if you just turn on this knob, it's going to show you there's no job running. And what I'm going to do now is in my data prep, I'm going to click on run job. When I click on this run, it's going to ask me, please let me know how you want to run. So there are two options which it provides: trifecta, proton. So run a trifecta proton, so which I'm not sure because this is their own product or something. Or you can run it on a execution environment or an environment where you can run a job which is data flow. So you can set your data flow details where you want to have it. You want your data flow to run in those regions which is there, the endpoints. So you can select one of them, and the machine type. Any advanced settings you want to do, you can do it. We have to do it because we don't have a default VPC. So custom. So we have to do we have to set it up because we don't have it. So let me see whether I have to. Okay, this is how I have to enter it. So the name is, we can use it from this job. I remember we did some specific setting for our network. I can click on clone. I'll get the details. Something like this. So it was ran in Singapore. So let's make it in Singapore. This is because we don't have a default VPC, and the region has to be Singapore. Awesome. And I can get my subnetwork. I guess this is not required. If you just mention here, if you see the same thing, we did not mention the network. We just mentioned the subnetwork details. That's it, folks. So you just mention the details of your data flow, where it has to run, what kind of machine type you have to use, all those things. Click on run. So when I click on run, it's going to create a job. So could not be details also. This is the VPC name. I'll give the VPC name also. Hope it works now. Click on run job. Specify subnetwork cannot be validated. Try to retry. Please edit the settings. Subnetwork is all good. This one, Singapore. Okay, US Central looks good. Not sure what is the issue. Let me just see it. Asia, and they had mentioned the same format. Let me just run it, folks, and see whether it is going to run. I'm going to ignore this warning and see. So at least the error is going to show me that. Now what's going to happen now, if I go back to my data prep, I should see a job, a new job, if things are all fine. If things are all fine, I'll put this here so that it's going to show a running job. Let's just see what's going to happen. You can also click here to see it in the data flow. Now let me just refresh this. That's it, folks. You see a job getting created in your data prep, data flow. If I click on this, you'll see the complete DAC. So for your transformation, data prep has created a complete steps. These are your DACs, directed acyclic graph. It looks little complex. They have it it has been built by them, and it uses primarily Java. So, and the type of job you saw last time was a streaming job. Now this time what you see is a batch job. What you see is a batch job. So it's going to take a couple of minutes for it to finish the job. Once it finishes it, it's going to store the data in a Google Cloud Storage bucket. That's it, folks. Now the whole part is for a person who's not well versed with Apache Beam pipeline to quickly do a proof of concept. You can use DataPrep. You can use DataPrep. So it's going to take time for it to finish. So, and anyway, it's going to finish it off. Once it finishes, you see the transformed data. You'll see the transformed data with your department, all those things. Since it has a source as BigQuery and Google Cloud Storage, you can dump your data into BigQuery and Google Cloud Storage if you want. And there are other few options where you can schedule this run. All those options are there. All those options are there. So that's your data prep, folks. So now it has started completely. So soon it should get finished. Soon it should be finished. So the key part which I wanted to share here is so different options we have seen so far. Data flow, if you were to compare it, data flow versus Dataproc versus data fusion, definitely everybody will expect this, versus data prep. If you were to do a comparison, the way I would say is the base is you need to have a programming knowledge. So if you have the programming knowledge, you can use Dataflow or Dataproc. If you don't have it, your organization has a limitation of that skill, then data fusion or data prep could be used. So a quick comparison, if I put it, insert a table. So data flow, data proc, these are something like I would say low level. Data prep. So you need Apache Beam. You need to be aware how Apache Beam works. So here it's going to be Hadoop, Spark, PySpark, those jobs which we have seen, 6 jobs or so. PySpark, uh, Spark SQL, Pig, and there was one more job, Spark. There was one more option actually. You can see it. The job is finished. The job is finished. Your data flow job is finished, and you should be able to see the transform data there. So, and once a job batch job finishes, right, it is going to automatically get stopped. Automatically get stopped. But a streaming job does not stop. You have to do it. Yeah, Hive. Thank you. Yeah, that was Hive. So these are the types of jobs which you have. So here, basically, you're going to use again. You are going to use something called as scoop jobs. Is it scoop? Yeah, scoop jobs. Here it's going to be again Apache Beam pipeline only via user interface, via data prep user interface. So that's one thing. So this one, what I would say, basically requires Python skills. This one, Java or Hadoop skills. Yes, Data Fusion supports streaming. So it supports streaming. So we had seen it, but we did not do a demo there. So it supports streaming. Hadoop, Spark skills. Basically, Java is what I would say. Java or Scala skills are required. Skills required. Here, none. You just need to have a UI because everything is UI driven. You just use the UI. So same as here because it's UI driven. Here you write a code. This is UI, and if I just go to the pricing details just to show you, it supports streaming. Uh, you see this, Vivek? Streaming jobs, streaming pipelines based on your this thing. So developer edition, so basic edition, enterprise, they all support streaming. It just based on your source. If you use a source which supports that, you can definitely use it. So the last time when we did the demo, it was a Google Cloud storage bucket. So we had to use a stream batch job basically. So this is how it looks like basically. So price wise, I would say data flow, data proc is almost going to be the same. So how many nodes you are going to be priced? Pricing is basically based on uh, based on GCE, basically virtual machines. So same as the cost with your data prep also. Data proc. Here you have a different pricing model, little expensive. Uh, you have a different pricing model for data prep also. So these are little pricey if you see it. So if I just go to my marketplace, I heard, I have not done a full analysis, but I heard from one of them and one of the subscriber in the YouTube, they're saying somewhere I had seen it. They mentioned data prep is little expensive than data fusion, uh, and it's not even Google product. So if I just search for data prep, why I came to marketplace is just to see the pricing. So pricing. So the pricing is little expensive. So those are some small comparison, folks. Like the fundamentals are either Dataflow or Dataproc. They have built UI on top of it. You can get basically scoop jobs executed via Dataproc. So data fusion and data prep are user-based interfaces where you don't need to write a code. Now, there are some talks I have heard, actually, I also heard it from the product manager in one of the videos, where in future, you may also have an option to run it on Dataflow. So now the execution engine is Dataproc. So via, like how in data prep you can do it via data flow, you may have the same thing in data fusion also, one of the execution engine. It may come in the future basically. So that's something on the data prep, folks. Any questions so far? So the whole reason for going through it almost for 45 minutes is only to make sure uh, you are aware of it. And I have seen one of the customers said totally straight away no, just because it was a 3P, a third party. And the reasons is the consent. How many times you have to give those consent, access to law, this thing, storage bucket, all those things. So they were not comfortable with it. They told even if the proof of concept takes 10 days, it's okay. So we had given a SOW saying that statement of work. If we are going to use basically data prep, we can do it in 5 days. If it's something else, we have to have at least minimum 10 days. They told 10 days is okay. So, but we are not comfortable with data prep. There's a question: does Databrick is also a data warehouse? Databrick, my exposure on that is limited, Vivek. So, but there is an option. There's a partner solution there, but I have not explored that, Vivek. So it's a partner solution. You can get it as one single invoice, but not explored much on Databrick basically. So somebody who have worked on Databrick can comment. Databricks, I've not explored it. And anyway, it's not a GCP so this thing. So okay, it got GA. Okay, okay, got it. So since you mentioned GA, wanted to talk a little bit about. So that's on data prep, folks. So hope it is clear. Any questions on data prep? Keep it handy. You may expect a Salu question on this. I had seen this in my 2018 exam. Missing anomalies, missing values, and was really shocked to see data prep in a cloud architect stuff. Data prep, and this is going to be heavily used by data engineers. So in a data engineer asking this question is okay because they would have done this, but for a cloud architect would be a little tricky is what I felt. But since I had taken the data engineer exam in 2018, so it was easy for me to answer. So then where is I understood as a cloud architect, you should know at least every product one liner of it. What is it basically? That's going to help you out basically. So any questions on data prep so far, folks? Okay, so if there's no question, we'll move on to the next part where we are going to see a kind of pipeline which needs to be orchestrated, scheduled, something like this. What is the product which we are going to use? And this is the kind of stuff which comes very regularly as a requirement. So how do you use it is what we are going to see. And maybe once we come back from the break, wanted to share, or I'll just share it right away. So if you go to your dashboard, folks, like the two ways where you can keep track, like because Vivek mentioned this product, Databricks went GA. So you can keep a track of what is happening. So either you follow the Google blog every day, or you come to your GCP console, just look into this news. You'll get lots of information, and that to this one is an important one, which I usually see. What's new in Google Cloud? If you click on it, there are a couple of good newses there, some new launches or something, um, some hard disk uh, maintenance using predictive maintenance, which is really a cool feature. Some chatbots or bot, and this one is something which attracted my attention. Basically, there are other few things which I did. Databricks, this is what Vivek was talking about. So by just going to this once in a week or twice in a week is going to keep you up to date. So this one was something which was attractive, folks. If I click on it, people with other cloud platform will really appreciate this stuff. So one pager, and I would have seen this kind of stuff in LinkedIn. Many people post it, but it may not be up to date. But this is from an official source. Definitely, people, the team who did it would have done a good amount of verification vetting. So products, like for example, the one which we have seen so far, App Engine. That's in BigQuery in GCP. If it's in AWS, it's going to be called as Elastic Beanstalk. If it's in Azure, it is called as Azure App Engine. So this could be a one single pager for basically to compare your different products. One single pager. So previously it was in two different pages. Now they have put it in one single page. Very massive amount of data. You can just directly go use. So NAT. Every cloud provider has a NAT offering. So Cloud Armor, we had Cloud Armor. So they have something called as Web Application Firewall rule, Azure and AWS. So good amount of stuff. There could be some products which Google is not supporting. There could be some products which Azure and AWS is not supporting. But this is a good place where you can explore lots of stuffs like this. Nice place. So keep a. I would suggest to bookmark this one, folks. Going back, just because Vivek mentioned it, I got this one. I thought let me share you this. Now let's go back to this kind of a requirement. Now we have a pipeline, and this pipeline needs to be scheduled. So basically, what we are going to do is now have a workflow like something of this sort. In on-premise, you have some Hadoop jobs. Uh, you have Hadoop jobs, and something is running in on-premise, then that data needs to be transferred to Google Cloud Storage and later to BigQuery. And this has to happen at a specific time. If the data comes at 10 o'clock in the night, the data should be transferred to BigQuery, all those things with some transformations, all those things. And I should get a notification in a Slack. And if the data by mistake does not come at 10 o'clock, even at 10:15 it comes, data should still continue to, it should definitely do that. Basically, the pipeline should get executed. It should be basically orchestrated and scheduled, all those things. So if you want to have this kind of stuff, um, usually different organizations use different kind of schedulers, um, control M, lots of stuff. One such product which you can use, which is again open source, and Google provides it as a managed service, is called as, you can do this kind of a stuff using a product called as Apache Airflow. So uh, this is a open source workflow and orchestration solution which can help you to author what component should come after what, and how to schedule them, and also monitor the flow. So Apache Airflow. So this is a open source product. You can install it on a virtual machine of anywhere. But what I've heard from folks is this setup itself is little tricky. It's going to take little longer time for you to set it up. What Google has done is they have provided you a managed version of it uh, in GCP called as Cloud Composer. So you can just use Cloud Composer, just click on it, provision it, and use your Apache existing Apache Airflow jobs to be migrated to Composer. So because it is open source, right? Many people use it in on-prem. I have seen one of the proof of concept where they wanted to move from on-prem to GCP, and it was basically a uh, Apache Airflow migration. So all the pipelines which they had, usually Apache Airflow supports only Python, no other languages. You have to write it in Python. So if you have already written a pipeline which can do something like this, basically you just copy that Python code with slight modifications in that Python code and upload to a Google Cloud Storage bucket. Remaining everything is going to automatically pick up the stuffs. So you just provision whenever you have a Airflow to a GCP migration from on-prem to GCP migration, and that is only Airflow. You don't need to do a real migration. What I would say is create a cloud composer, copy the pipelines to a location. I'll show you the location. Copy it, and things are going to start working. And it's going to support end-to-end integration for lots of GCP products, BigQuery, Dataflow, Dataprec, you name it, you are going to have a integration with it. So, and it's not only with GCP products, it also supports AWS and Azure products because it's open source. And there are good amount of data engineers who rely on this. But as a cloud architect, be aware of it. If there is a pipeline which you need to schedule it, and there's going to be on-prem GCP or other cloud and GCP, then Composer could be a good choice. Composer could be a good choice. Let me just do a small demonstration. We usually do a full-fledged demonstration of creating a pipeline, all those things in Python in data engineering class. But I'm not going to do that because as a cloud architect, we don't need to write a code. So I'll show you the infrastructure part of it. How do you provision it? And what are the things which you need to take into consideration? So this is one of the products which is going to take little longer time to get provisioned. The reason is you will understand it once we finish the demonstration. Um, Basically, it uses one kind of a compute option, and this Airflow needs to be installed. It takes roughly around 20 minutes. Similar to your data fusion, it takes around 20 minutes to have it up and running, not like other stuffs which gets provisioned so quickly. So I'm going to just create a very basic demonstration and show you how the Airflow uh, page looks like, and also uh, what is that? How if you have a DAC, if you have a directed acyclic graph written in Python, how do you load the stuff? So basically, I would say the reason for showing this demonstration is you will see concepts like manage instance groups. You'll see concepts like Kubernetes engine. You'll see how Google Cloud Storage Bucket is used. You'll see how IAP, Identity Aware Proxy, is used. All those components. It's like using these raw or using these fundamental components in GCP. How can you build a complete application? This is a highlight of that. So you're going to see managed instance group, Kubernetes, Google Cloud Storage, and IAP all in one single demonstration, folks. So from the infrastructure, if you were to see it. So to do that, let me just go to my composer. Click on composer. Maybe the API needs to be enabled. I'm not sure. Let me just see. Yeah, so manages Apache Airflow environments on Google Cloud Storage, or sorry, Google Cloud Platform, enable it. By the time it gets enabled, I wanted to show you the current status. I'll go to Compute Engine. To show you the current status, nothing there. I'll go to my Kubernetes engine. If nothing is there in Compute Engine itself, in Kubernetes engine also, nothing is going to be there. Nothing there. And if I go to IAP, these are the entries, folks. These are the current entries. Let's see what's going to happen. Now, let's create an environment. With a composer, you can easily create, manage Airflow environments. So a quick migration is going to be an easy option here. Let's give a name, batch6 composer, location. So not sure everywhere it's available, but let me choose. It is not available in Singapore, if I'm not wrong. Yeah, it is not available. I'm going to choose US Central only. So US Central. Now, here is where you are going to appreciate the Kubernetes concept which you have learned. So the configuration information on Kubernetes running. So it's going to create basically a 3-node Kubernetes cluster, folks. We know Kubernetes cluster behind the scene is nothing but a managed instance group. So all your concepts are going to be used here. So it's going to be a 3-node Kubernetes cluster, and it's going to be basically a zonal Kubernetes cluster. So if I select A zone, so it's going to be in US Central A zone. A zonal Kubernetes cluster is going to be created. You can mention the machine type. If you don't mention the machine type, it's going to be N1 standard. So disk, how much you want to mention, you can mention it. Or 20 is going to be the minimum. Sorry, 100 is the minimum. So default is 100. Minimum is 20. So I'm going to mention it as 30. Some service account details, you can mention it. If you don't mention it, it's going to take the default service account configuration. What is the default service account role which we have given? Because we play around with IAM sometimes. Hope it is editor role. Editor role, it's already editor role, so should not be a problem. So tags for some firewall rules. Now this is the important piece, folks. This is the important piece. Why? When you're doing a migration, you as a cloud architect should ask what is the version of your what's the version of your Apache Airflow running in on-prem. Then you can do a mapping in GCP. So asking that information is very, very important. So it gives you a mapping. So if it's Apache Airflow 1.10, it maps to 1.16.63 in GCP. So they have a mapping. So that you can use that. So any version which is 1.10 in the open source community, it is all mapped to 1.16 in GCP. So let me use the latest one. So, and it only supports Python, folks, nothing else. So Python 2 is end of life, so I'm going to use Python 3. And there are few networking stuff we have to do it because we have a custom VPC. So let me use batch6. Subnet is going to be US Central. You want turn on private IP, all those things, you can do it basically. And how you want it to be accessible anywhere from the IP address. So Cloud Composer is going to create a web application. That's where you are going to use it to do any kind of a migration. So whether this should be accessible from everywhere, the web server, or it should be controlled by a specific IP. You can mention it. There's some maintenance window, all those things. That's it, folks. That's it, which you need to mention. So basically, it's going to create a Kubernetes cluster, which is going to have a web server, and you will see how you can access it. So let's go ahead and so it's going to create. Okay, the web server, this one was not actually available in the past. So now, if you look into the pricing of a cloud composer, there is going to be two costs. One is a Kubernetes cluster, a 3-node Kubernetes cluster. The other one is a web server which gets provision. So there's going to be two billing which you need to pay. So configuration of the app engine flexible instance running Apache Airflow web server. So any pipeline runs in your data in your Kubernetes, that's the infrastructure. And there's going to be a web user interface, which is very clearly mentioned. It's going to be app engine flexible. But this is not going to run in your project's app engine flexible instance. It is going to be a tenant project. It's going to be a tenant project. So you see App Engine, you see Kubernetes Engine, you are going to see Managed Instance Group, you are going to see IAP, and you are going to see Google Cloud Storage heavily used here. So, and the minimum here I can mention is only this. So 2 vCPU, 1.6 GB of RAM. This is the new feature which is added. Previously, you did not had that option. Now they have created it. Now let me click on create. So Kubernetes cluster takes around 4 minutes, default Kubernetes cluster itself. Now, if you want to have Apache Airflow related stuffs, and we have also seen flexible instance, the simple hello world itself is going to take 7 minutes. So to have your web server, all those things coming, it's going to take roughly around 20 minutes. So what we will do is we'll take a 10 minutes break. Once we come back, if it has come up, we'll definitely do the demo, or if it takes time, we'll come back after some time and do the demonstration. I just wanted to show you how the web server looks like. Currently, you see the web server, it is none. It should show a hyperlink, and the authentication to that hyperlink is controlled by your IAP. So let's wait for it. It should get created. I can quickly see, is there any changes in my Kubernetes cluster page? Nothing. Anything in my virtual machine screen? No. So let's wait for it. Maybe we can take a break and come back. Let me stop the recording.
This conference will now be recorded.
So it's almost 10 minutes. We provisioned it. So still going on. And if I just do a refresh, it's still going on, but the backend components are slowly getting created, like your virtual machine, 3-node virtual machine, because this is nothing but a Kubernetes cluster. You should see a Kubernetes cluster. You see the Kubernetes cluster. The Kubernetes cluster is up and running. So it's up and running. So your managed instance group, which is going to be used behind the scene, is up and running, but the software inside it is going to take some time to install. So we have to wait. Now it's really a good thing where you can go and explore certain stuffs. You know Kubernetes, how it works. Go look into the details. What are the components it uses? You'll come to know. You'll come to know. So the stuffs which we had seen does not have the minimum availability. That's okay. I have to see what is this error. So, or we have to wait for it. So you see some stuff, folks, already. Some of the workloads, deployment, monitoring. There's going to be a Redis instance because it's a database. It is a stateful set. Scheduler, there's one workload. SQL proxy. So Fluentd, which is for logging purpose. So you see the concept which you have learned, they have put in action here. So if you look into the services and ingress, you will see certain stuff, and most of them are cluster IP, which is going to be internal. So this is how exploring the stuffs basically. The fundamental is clear. Now using those fundamentals, they have created a service out of it. So that's what you see. So let's just give some more time for it to finish the installation. Usually I've seen it takes minimum 20 minutes. So 10 minutes already over. So once it comes up, you should see a URL. So let's leave it for now, come back and see how it's going to happen. The next concept which we are going to see, this is purely from the exam perspective only. So so far we have seen different ways of writing a pipeline in Python, in Java, in some cases only in Python, all those things. There should be an environment, right, for someone to write a code. So either you can run it on your local machine, uh, a Mac machine or a Windows or Linux. Uh, but if you want to use a distributed architecture kind of a stuff, then running it on something like Dataproc is going to be a good choice. Uh, but if you wanted to run it on a single machine, but with all the latest features, say for example, use GPUs, more like your local laptop, but with GPUs, all other additional components built in, then you can use a product which Google provides. Previously was called as Datalab. Now it is called as AI platform notebook. The reason why I wanted to mention that name Datalab is, who knows if the questions are not still updated, one or two questions somehow got missed for update. If you see something, it's nothing but a AI platform notebook. So what does this basically is, on a virtual machine, it's only one single virtual machine is what you get. You get all the necessary software for you to run anything via Python, anything via Python, or uh, either you can run any of your SQL queries, anything of your choice via basically this Jupyter notebook. So AI platform notebook is nothing but a managed Jupyter notebook. For folks who have never seen Jupyter notebook, I'll show you how it looks like when we do the demonstration. So this is browser based user interface. You just create your AI platform notebook. We'll talk more about AI related concepts in our module 7, mostly next Saturday. We should be talking about it, or Sunday. Basically with this, you can play around with your Python stuffs line by line. So the reason why people use Jupyter Notebook is it's very interactive. So for learners, this is going to be really helpful. You write a one line of Python code, execute it then and there and see it. Because Python is an interpreted language, so it works very well there. So you can run each line by line and you can see whether it is syntax free and it's going to run or not. And basically, as I mentioned, it entire stuff, if you ask me, it's nothing but like more like a marketplace offering. So you have a virtual machine. On top of it, you will install Python, you will install Jupyter Notebook, then you will give a user interface. Just log in and try running it. And you can run various commands via it. And you can also run CLI commands like gcloud commands, bq list. You can also shut down your machine from your AI notebook. You can do all those kinds of stuffs very easily. So basically, this is a place where the developers can write a code and deploy it into Dataflow or into Apache Hadoop or Dataproc, basically. So this is going to be like more like an environment, development environment. So why, as a cloud architect, you should be aware of, if the developers come back and say, we have a laptop where we cannot write a very long pipeline, long running pipeline, we need a better compute option. Instead of running it on their laptop, you can provision them a infrastructure called as AI platform notebook, using which you can change the machine type if they want more. Or in one of the cases where I have used AI platform notebook is this organization A. So if I take this organization A, they have a requirement of writing a pipeline, a data pipeline in Python. Now that organization does not have the skill set itself. They don't have the skill set. Now what they did is a contractor, uh, from a different organization called as organization B. Now what they wanted is, they just wanted this person to write the pipeline, give it to them. So this pipeline relies on BigQuery and Google Cloud Storage. So what they did is, they asked me this requirement. So this is how it has to be done. So what I did basically was, uh, created this employee. So assume this is user one. So I created basically user one at the rate organization b.com, the email ID of that user, gave this user the permission to launch a Jupyter notebook. So there's something called as notebook admin and BigQuery job user and BigQuery data viewer. Just need to read the data from BigQuery and storage object viewer role. So these roles I gave. Now he's able to launch. Now the data he's never going to keep it in his laptop. He's going to use everything in Jupyter Notebook itself, do all the stuffs, and that's it. So it's going to be a property of organization A. So this is where you use your IAM concept and also making sure the business requirement is fulfilled. Business requirement is fulfilled. So let me just try to launch quickly a AI notebook, AI platform notebook, previously called as Datalab. So before we do the data flow, AI platform notebook stuff, looks like our composer instance is up and running. So roughly took around 15 minutes to 20 minutes is what I would say. Uh, this is what I was saying. So you should have your link basically. And before I do that, just wanted to see, is there any more additions to my stuffs? Is that error message? Okay, that error, there was some error, right? Something was not fulfilled. It is now fixed. So your cluster is working fine. Now let me see the IAP. Is there any changes in my IAP? Any entries or anything of that sort, or something which is not going to be shown here? Uh, okay, nothing here per se. It's not showing, but you will see it once I launch my uh, Airflow web server. So Airflow web server, as you saw in the provisioning stage, it is going to be an app engine flexible instance. So click on this. What does this screen indicates, folks? What does the screen indicate for you? Login screen, I know that, but anything apart from that? Folks, what does the screen indicate? Apart from asking for you to log in, uh, folks, you are there? Yes. Authorization for IAP. So basically it shows how IAP is used and why it is not showing in our IAP. I'll tell you in a minute. But it really shows the stuffs which you learned, components which you learned, they have put in action. They have put it in action basically. So iap.cloud Google APIs.com. So it's basically using your identity aware proxy concept, which we had tried it with our demo also in our demo. So let me click. Now this is your Apache Airflow page, folks. Now this looks exactly the same in your on-premise, in your GCP also. So you can load DAC and it's going to show up the stuffs here, basically. So I'll show you a small demonstration on that also. Before that, look at this URL, folks. Look at this URL. Now, any thoughts on this URL? Any thoughts on this URL, folks? This is an app engine URL. Yes, absolutely correct. So this is an app engine URL. But what does this TP indicates? It is a tenant project. This is a tenant project which is going to reside in not your project, in some other project, which is going to be usually accessible by APIs and all. We will not be able to directly access it. So in that project, if you go, you should be able to see the IAP configured there. And that's the reason we don't see it in our project. But it's going to be charged to our billing account. It's a tenant project. Now, assume you have a pipeline. So you have a pipeline, you want to deploy it. How do you do? Basically is very, very simple. So you see one of the DAC. So what does this do? Basically it does just airflow monitoring. So if I click on this, it just does an echo whether health check. It does like more like a health check whether it's all good or not. So you can see some different views of it. uh, just an echo command, nothing else. Now if you want to have a new DAC running, where should I upload it would be a question. So in on-premise, they will do it in some disk, onto a disk. But in GCP, they don't do it onto a disk. They do it into a Google Cloud storage bucket. This is your DAC folder, folks. So when I click on this, it takes me to a Google Cloud storage bucket. This is the bucket which is going to be created, and you will see a py file, Python file. So if you click on this, you will see the content, or let me download it, folks. So this is the content. This is the content where it shows, this is the name which is going to be shown in your Airflow web application, what name you want to see and what it is supposed to do. It's going to check the liveness, whether it's up and running or not. It's just going to do an echo test. That's it. Now what we'll do, we are just going to copy the same code to my local machine. I'll call this as batch 6 monitoring. It is downloaded. Let me open it in my Notepad++. So this is the stuff. Now what I'm going to do is do some small modifications. We are not going to do write a code. I'm using an existing code and do some modification just to show you how do you do the migration basically. So I'll call this as, batch 6 demo. Batch 6 demo Apache Airflow monitoring. That's it. So this is the stuff. Now I have a new pipeline written in Python. You see it is using Airflow modules. Now what I'm going to do basically is to do a migration. Assume this is the stuff which I have in my on-prem. You don't do anything here. In the Apache Airflow page, you basically go to the DAC. You need to find out where is the DAC. So you can get that very easily by just going to your composer, clicking on this DAC folder. So if you do that, simply go and upload it, folks. That's it. Just upload your new Python file. It's going to reflect in few minutes the changes. So let me upload it. It's on my desktop. That's it. I have uploaded my py file. Now if I just wait for a couple of minutes, it's going to detect that there's a new pipeline added and it's going to show me that. So let me just refresh it once. Still not there. Let's just wait for a couple of minutes. Should show one more entry, basically called as what is that called as? Batch 6 underscore demo underscore airflow underscore monitoring. That's what it should show if things are all fine. So, or we can see the logs also, see what is the issue there. If there's any issue, or because we just, okay, you see it, folks. And this pipeline has not even executed at least once. So it's going to run every 20 minutes. Every 20 minutes it's going to run. So we have to wait for 20 minutes more. then you should see it has successfully run. Now this has run twice. It has run twice. Now if you want to run it immediately, you have also the option trigger the tag. Just click on trigger. It's going to trigger it if you want to see it right now. Now it is currently running. After it is running, it's going to come to state as run. The dark circle is going to show basically it is run successfully. So let's just wait for it to finish it. So there's no refresh button here. I have to refresh the browser itself. Currently running. So, and if you don't want this to run, you can turn it off. You can schedule it at what time you want to. If it fails, what is a repeat, after how long it should again repeat, retry it. All those things, the entire orchestration scheduling, you can use it. And I have seen one of the customer where I worked, they use this purely as a enterprise scheduler. Instead of control M kind of a stuff, they wanted to use this as their uh, enterprise scheduler, because control M is expensive is what I heard. I'm not sure of it, but this is open source, and what you need is just an infrastructure which you can get it easily in GCP. Now the job which we have is run successfully, and if you want to see the code, actual code, you have this option. What you uploaded, you should be able to see it by just clicking on this, the same code which you uploaded. So for troubleshooting, this could be helpful. So that's on your Apache Airflow. So in my data engineering class, I usually do write a code and upload it and see how it works. But I wanted to keep it very simple here, where you understand how you do the migration and the infrastructure behind it. Any questions on this, folks? Any questions on this so far? No questions? Okay, if there is no questions, let me just delete my composer instance. And please note the drawback of it. We saw all the good features of it. What's the drawback of cloud composer? If you ask me, the Kubernetes cluster is the drawback, because you cannot stop a Kubernetes cluster. So you have to make sure you pay for your Kubernetes cluster, the cost. So if there is a requirement where you are going to run continuously workloads one after the other, composer is really a good choice, only if you want to use only for scheduler, nothing else. Just schedule this job, this pipeline. For that purpose, I'm using composer. Means I would say, think, is there any better options? I myself have avoided using composer in couple of scenarios because it was very simple requirements, something of this sort. So the requirement was, there is a GCS bucket. The moment data comes to storage bucket, new data to GCS bucket, it should be transformed and stored in BQ. This was the requirement, folks. So for this, one of the existing architect had put cloud composer. A good fit, no doubt in it, because you want to do this uh, whenever it comes, when a new data comes. So but the problem here is Google Cloud Storage serverless. You are going to use transformation, then definitely you're going to use Dataflow. They had mentioned Dataflow only in the architecture. It's a batch processing job. So Dataflow and BQ. So this was the option which the person had mentioned. GCS, Dataflow, BigQuery, and the entire pipeline orchestrated by Composer when the pipeline should run. That is the part. So it was basically as a scheduler. Now what I proposed is, I propose something like this: cloud functions, that is going to call your data flow, then your BigQ. This became totally serverless. Now the moment both has drawbacks by themselves. It's not that one is superior to other, but from the cost perspective, this was cheaper. Why? So what was happening in this logic is the moment you upload now to a file to a Google Cloud Server bucket, this is going to trigger a cloud function. We know cloud functions can be triggered by a storage bucket, a PubSub topic, or by an HTTP URL. It is going to immediately call the data flow endpoint. So it's going to call that endpoint. Using the endpoint, it's going to call that specific job, runs it, does all the transfer. If the data flow starts, the pipeline is going to run, the transformation is going to happen, it's going to insert it into BigQuery. So this was totally serverless. But what is the drawback of this? If you upload multiple files in quick succession, you will have multiple jobs created, multiple data flow jobs created. You may run out of quota. That's the drawback of this logic. So if I go with here, it's not going to trigger immediately. The composer you would have mentioned at 10 o'clock in the night only you run it. So if you want that kind of a stuff, then composer logic is going to be good. But if you want a cheaper solution, you can go with serverless, because here it's going to be a managed service. So, and you cannot stop your composer. The only way is you have to delete it. Behind the scene, it uses Kubernetes, and we know Kubernetes cannot be deleted. So you have to make the number of nodes 0. Bare minimum, we can do that. Which is going to have implications if you again start it. So think of composer whenever you are using it, and you cannot quickly create it also. It's going to take around 20 minutes. We saw it by ourselves. So use it effectively. So if this composer is going to be used heavily by multiple pipelines, and it's going to be continuously used as a scheduler throughout the day, then having a dedicated scheduler is going to be a good choice like this. Or if you want, you can also use a serverless scheduler called as cloud scheduler. It's just only scheduling, nothing. At specific time you say it is going to run. It's more like your cron tab. You can also use this, uh, which could be a good choice if you want. So think of which options to use. Wherever, if the customer says we want cost effectiveness, all those things, serverless is going to be little good option. And this approach which was taken was really appreciated by the customer. So they did not had any composer requirement. They wanted to just schedule it, that's it. So I told this option would be a good, so they told okay, let's go ahead. So deciding what component, this is the true role of a cloud architect. You are making the solution cheaper, cost effective, and at the same time it is really working, and you are not incurring lots of cost by running these things. So let me just delete my composer if you don't have any questions. So composer deleted it. That's it. Now let me just do a small demonstration on AI platform notebook. So as I mentioned, this is just a virtual machine with all the necessary software installed, which is going to be really helpful for a data engineer to develop a pipeline. So I have seen in one of the organization, most of the data engineers spend their time in AI platform notebook only. Morning they open it, till the evening they keep it open. So they only work day in day out on this. So that's basically good, and they do everything on GCP itself instead of doing it on their local laptops. So that's a good choice actually. So let me just provision one quickly. Let me see whether the instances are going down. It's going to go down. So how do I access my AI platform, a notebook? So you have to, and this has to be discussed in the AI section, but Dataflow was previously, sorry, not Dataflow, Data Lab was previously, in the beginning days, it was under big data category. Now, since it was moved out, so I thought, let me explain you AI platform notebook right now, to basically, because we have seen lots of AI, sorry, lots of big data concepts. Now let's see how we can help a data engineer to write his or her pipeline. So under AI platform unified, if you see, you will see basically notebooks. Just click on notebooks. So the AI notebook, so this is how it looks like. Basically, if I just see my virtual machine screen, so it's going down. What I'm going to create is I'm going to create a AI platform notebook in one of the regions. So let me create one. So when I click on create, you get lots of options. This is where a developer will really, a data engineer will really feel happy, because if you just give a virtual machine, the developer or the data engineer needs to install TensorFlow. These are all your AI or machine learning frameworks. So enable it on GPU, TPU, all those things are going to be a hectic task. So here everything comes as packaged. So just go use which one you want, which specific package you want, you can start using it. So pre-packaged stuffs. I'm going to use this one, Python 3, which has going to have some Python related components, and I can play around with it. So let's give this name as batch 6 AI platform notebook, which is nothing but the virtual machine's name, folks. That's it. So I'll put it in US Central only, folks. Quickly, I can provision it. It's going to choose by default. It's going to be 4 vCPU, 15 GB of RAM, N1 standard 4, basically. This is what it shows, basically. If you want, you can do some further enhanced fine tuning to your this thing. So basically your virtual machine skill set is going to come. So what is the operating system you want to choose? Either Debian or Ubuntu only available. uh, if you want to change the machine type to lesser, you can do it. GPUs, you want to add it. If it is available in that zone, you can add it. Boot disk, you want to reduce it, you can. Networking, we don't have our own default VPC, so you're going to use a different VPC. All your stuffs, your IAM, your service account, all those things, you are going to use it basically here. So all your basically your compute engine skill set is going to come here. Once I click on create, what's going to happen is it's going to create a virtual machine here, virtual machine here, and it's going to also have a user interface where you can go and access this virtual machine in a browser. So let me just do that. So getting created in US Central. If I go to my virtual machine screen, it's created. It's already created. It's going to take still time. It's almost there. Let's just wait. Waiting for a link, folks. It should show a link. You see it is creating a proxy. So using which I should be able to connect to my AI platform notebook. Now I can just SSH into it from an infrastructure perspective, but I don't want to do that. Basically, what I want is give basically the access to the developer to access a data engineer. So the role which I would usually give is click on this only if they have multiple notebooks. You want to give one specific access to one specific notebook to a specific group. Basically, it does not show here. I have to rely on this one. So click show info panel, and this is what exactly I did actually to that one user, added him. So I'm just going to take this as person as the user, and I'm going to give this one, folks, notebook admin. So for that notebook, he can go do everything, install any stuffs, components, all this kind of a role you can give basically. So let's see. Yeah, now the notebook is completely provisioned, and this is the most important piece. Open Jupyter Lab. So people who have worked on Python Jupyter Lab, you should be able to get familiar. You should be able to see a familiar screen, a very familiar screen. But for folks who have never seen Python Jupyter notebook, you should be able to see how it looks like. And maybe if you wanted to learn Python, this could be a good place basically for you to explore it. So Jupyter Lab, this is how it looks like, folks. So now you can go ahead and write your Python code, or you can write something in terminal also. So I'm just going to write a small Python code, just hello world, nothing else. So print, and these columns are called as cell. Uh, hello to batch 6. Now, if you want to run it, you just click on this play button. It's going to run it. And if there's any error, it's going to give you that message. So for example, if I do a typo, if I run it, it is going to show it is not a defined method. So very simple. I can know then and there itself what is the issue. So this is really a cool feature. So people write massive amount of code in this, the data engineers. We are not going to write it, but I wanted to show you this part, how it is going to be helpful. Now, the developer, if the comebacks and says my notebook is slow, you have very simple option. Just go change the machine type, and that's it. You're going to give him access, like it's going to be upgraded. There's going to be a slight downtime because you have to stop it and change the machine type, and he should be able to run it. But if the same thing happens to a normal laptop, if a developer says my laptop is slow, changing the laptop is not going to be so easy. It's going to take a long time. You have to go for an approval process, all those things. But if you use AI platform notebook, it's very simple. In next 5 minutes, I can have a better configuration, give it to them. So you see the value of cloud there. Now let me just show you a couple of stuffs which we can do. I'm really a fan of this magic sequence or magic command, where I do bash percentage bash. After doing this, whatever you write is going to be basically a command which you can write it in Linux in your command line. This is basically on Linux, so any Linux command you can run it. So it's going to show basically what's your current working directory. Now if you want to see any other stuffs, you can run it. So you want to run it in the next cell, add a cell. Now you want to see whether gcloud is installed, because it's a virtual machine. Definitely gcloud should be installed. Yes, it is installed. Now you want to run something more, because any gcloud command is going to work, any bq command is going to work, any gsutil command is going to work. So now you can do gcloud compute. Let me just little make it bigger. Compute instances list. It's going to work. It's going to work. This is the same notebook which is listing it here. Now you want to see basically your buckets, run your commands which you know. So gsutil ls, it's going to list you one or two buckets. One which was created by your DataPrep, the other one was created by your composer. Now you want to do something with your BigQuery, you can also do that, because you see BigQuery stuffs are there. So you can just go use it. So BQLS is going to list my data set. Awesome. So you can use this even in this way also, basically, and you can run any Linux commands, any gcloud commands, any bq commands, or gsutil. So if you want to learn it via a small interface like this could be also an option. And you don't need it. You have the option of stopping it. And you can also use this instance schedule. Maybe on Friday, Saturday and Sunday, nobody's going to use notebook. You have a scheduled stop on Friday 6 o'clock, morning Monday 9 o'clock, you start it. You can have that kind of an option where you can have a more cost effective option, because that's at the end nothing but a virtual machine. So that's something on your AI platform notebook. Basically now at least you would have got a view how a Jupyter Notebook looks. Jupyter. So this is like managed version of Jupyter Notebook. So this is how it looks like, the Jupyter, and they usually end with dot IPYNB. So interactive Python notebook. That is the extension actually. Now, if you have a Python code, you have to copy line by line, or there could be options where you can import and export to a notebook format, basically. Now, if you want to save this file, you can put it into your GitHub repositories. So demo, push this to your GitHub repo or something, and make sure you keep a track of it. That is also possible. So that way the data is never lost, basically. Any questions on platform, folks? AI platform, notebook? Today you people are a little quiet. So got it, fine. So if it's clear, so now you see why we spent a good amount of time on our fundamentals would be becoming very clear. So you saw Dataproc, which was nothing but virtual machines. You saw Dataflow, which was nothing but managed instance group. You saw Composer, which was nothing but a Kubernetes cluster, a managed instance group stuff. Now you're seeing AI platform notebook, it's again virtual machine. Now the infrastructure is, once it is clear, your big data concepts becomes very, very easy, basically. So let me just delete my, I can stop it, but I don't want to keep it. I'm just going to stop it. Is it basically, it is basically used to write Python code. Yes, you can write Python code. Along with that, you can also write SQL statements. So SQL, JavaScript, you can write it. So not only heavily used by Python, but you can also use it for SQL, writing SQL, JavaScripts, stuffs, basically. You can do that. So there are some modules, if you install it, you should be able to do that, Vivek. But most of the time people spend time writing Python code, because it's basically, by default it's going to support. Now if you don't want to write Python code, you want to write something like R, uh, a kind of IDE, but it's not on your laptop, because IDE has better integrated development environment. It has more features an IDE, but this is more like a browser based editor is what I would say. So if you don't want Python, if you want to write R, you can use this option. If you want something else, you have lots of options. So IDE is going to help you support, do debugging, looking into the logs, lots of other features. This is more like a browser base, and this is basically for collaborative purpose. Now I created my code. I can share it with you to continue working on it. So, but in an IDE, I have to upload my code into my source code repository. Then the source has to be accessed, all those things. So that's the difference. So that's the part. So in the exam, if you see basically data lab, it's nothing but your Jupyter notebooks. Just do a mapping so that you don't, you are not confused with that. So the next product which we are going to see, we wrote lots of pipelines. We dump the data into BigQuery. Now, nobody is going to run. If you see, take a C-level people, nobody is going to write select column names from the table where some clause, group by, order by. Nobody is going to write it because they are not comfortable it. So they want to have a visualization. So a BI tool is going to be a really an important one if you have finished all your pipeline. So nobody is going. The reality is nobody is going to look into the backend system. Always people will appreciate what is there in the UI. So the UI or a visualization is very, very important. And if the data source is basically a cloud SQL instance, a spanner instance, or BigQuery, then a free business intelligence tool which you get in GCP is called as Data Studio. And please note, it is not a GCP product, but it is a Google product. And that's the reason you will not see Data Studio in your GCP console. In your GCP console. So it was there, but they removed it recently. So a BI tool, a business intelligence tool. So you can, and please don't try to compare this with the sophisticated BI tools like sophisticated BI tools like Tableau, Click, Power BI, MicroStrategy, uh, um, all those kind of stuff. They are paid versions of it, so you cannot even compare it. Basically, for proof of concept, if you were to show some uh, user interface quickly with some bar charts, some trendings, all those things, you can use this option basically. And here you don't write a single line of code. You basically do everything in a drag and drop kind of a style. So no code required. So it's basically for visualization purpose. So let me just quickly show you one, how it looks like, how easy it is for you to explore it. So I don't have, I will use my BigQuery as my source. So if I go to my BigQuery, let me see whether I have any data. I don't have any data, everything is expired. What I will do is go to our this thing. Let me download one. Uh, let me download United States or Avro file. I'll just download it. All right. Now create a table. Call this upload from my local system. Call it as users. Because it's an Avro file, the fastest file format which gets loaded. The schema is going to be part of it, so I don't need to do anything. Just load it. Now I know how to visualize it in the BigQuery. By just putting a select statement, I should be able to visualize it. Or by just looking at the preview, I should be able to see it. We have done this. We have done this. Uh, but if you want to show it in a nice graph kind of a stuff, better visualization, then rather than showing it as numericals, what you can do basically is, this is the content. What you can do is basically click on this export option. It's a wrong button actually. They could have put it in something different, but I don't know what they meant by that. Export, explore in Data Studio. This is what you'll see. So you're going to explore the data in a BI tool, free BI tool from Google. So explore with Data Studio. So if I click on this, it's going to open a URL called as datastudio.google.com, and it's going to show you the same stuff which you saw. Peter, how many times, it has put its own query by default. If you want, you can fine tune it. All those things are possible. So you see those visualizations, folks. Pie chart, if you wanted to put, so how many times Samuel has occurred? 10 times or 11 times is what Samuel record has occurred. So it has put a small logic by itself to do a query. Now, if you want a different field altogether, you can basically do the use the role of a BI tool. So and do it. Maybe if you don't want by first name, you want to change it to the country. You see, most of the people who have registered is from China. The next is Indonesia. So that's what it shows. Now you want some different types of charts, you can use it. So you can use it basically. So that's how easily you can visualize your stuffs using your data studio. And what are the other data sources supported? You may ask this question. So to explore the data set or the data sources, so if I click on data studio here, I can see my data sources. I can click on, okay, there's only one data source which we just created. Create on data source. These are the data sources which you get. lots of data sources. Since I mentioned this is from a Google, you can also use this for your analytics purpose, Google Analytics, YouTube Analytics, lots of options. But if you are very specific about GCP, so just search for Cloud SQL. So Cloud SQL is there. So Cloud SQL for MySQL is there. So Cloud SQL for Postgres is not there. For Microsoft SQL Server is not there. But if you search for Postgres SQL is there. So they have put it in a different form. So that's there. BigQuery definitely will be there. You see it. Spanner is going to be there. Any other products? Bigtable does not show. There is no connector to connect to the Bigtable and see. Similarly, if I do Firestore, I don't have it. Data Store, I don't have it. Any reason why you don't have a connector for these three things, folks? Any technical reasons why you don't see it basically? So yes, the BI tool usually is for a SQL based system. For a non-SQL or a NoSQL database, usually you will not have a BI tool. So your data store, Firestore, Bigtable, these are all NoSQL database. So you cannot expect a BI tool for it. Now, if you have a requirement where data is in Bigtable, but you want to use Data Studio, what will you do, folks? What will you do here? So my source is CBT. The visualization is going to be Data Studio. This is confirmed. We don't have any option to change. Now, how will you do it? Any thoughts? Any thoughts, folks? How will you visualize it? We are very clear. If I search for it, if there was a connector, I would have done it. But it is not there. How will you handle this scenario, folks? Any thoughts? Simple. Load it into BigQuery, folks. So that's where we did this exploration in BigQuery, right? When you click on create table, I have other options. I would load my data into Bigtable. So the existing tables which is there in Bigtable, I'm going to have as a source in my BigQuery. Now it's going to create the tables in BigQuery. Now BigQuery has a connector. So you use BigQuery as your intermediate querying engine. And via BigQuery, what is going to do is it's going to translate your SQL. When you run any SQL statement, it's going to get translated to a NoSQL thing behind the scene. So the option is very simple. So use source, use this as your external table, load it to BigQuery, and you should be able to use your Data Studio. Simple option. So the connectivity part, this is again the true value of a cloud architect coming into picture. So you use the existing component and do it. So or you have to build some kind of a custom connectors. There are also possibilities where you can create connectors, custom connectors. There should be an option. If you search, there's a community also where you can search for connectors and build it. So, but it's going to take time. But a smarter way is use BigQuery as a with Google Cloud Bigtable as Cloud Bigtable as your external table. That's it. That's it. So that's on your Data Studio. So just be aware of this. There's a product called as Data Studio, which is a Google product, which can connect easily to some of the good SQL sources which we have in GCP. And this is totally free, so could be a good fit for your proof of concept, because usually proof of concepts are not funded. So use a product which is going to, because sometimes the customer will say use your own subscription and show us a demo. So who is going to pay for the subscription? So better use products which is going to be free like that. So prefer to use this. And we don't write code. Anybody who knows BI stuffs can just do drag and drop, change the stuffs, and you should be able to see it. So because it's a free tool, as I mentioned, it's not good to compare it with the sophisticated BI tools. Now, if there's a tender or something where you're participating, and if you position Data Studio, you may not be able to fulfill most of the stuffs there. So some real-time trendings, all those kind of stuffs, if you were to show BI Data Studio, may not work very well. And you have to propose use Tableau or something, a third-party product. Then again, that customer, if it's a public sector customer, they are going to ask who is going to pay how is the invoice is going to happen. So definitely you're going to get two different invoices, one from Tableau, one from um, Google. But if they say, can we avoid that? It is possible, where you use a better sophisticated product in GCP called as Looker. So this is a sophisticated BI tool which you can definitely compare with Tableau, MicroStrategy, Click, all those things. So Power BI. So you can definitely sing it. This is something really a good BI tool. Lots of BI capabilities can be seen, and this is an acquisition which Google did a couple of years back. So the limitations which you had in your Data Studio can be definitely fulfilled by your Looker. So what you can usually propose, where you can propose Looker is, as a proof of concept, you show Data Studio, satisfy the customer that these capabilities are possible. And if there could be some few things which is not possible with a Data Studio, that's where you can pitch in, basically saying that Looker could be a good choice, could be a good choice. And because it's an acquisition, it is from a different company altogether. It is not fully gelled with the GCP pricing stuffs. So there is still a separate sales team for Looker, all those things. So you don't get a complete pricing model. And what I heard is it is little expensive, basically. But how much, I don't know the details, but I just heard it is little expensive. So, and there's no much information on the public website. Even if you go, you'll see it is going to be saying reach out to sales for pricing details, basically. So a sophisticated BI tool which can do lots of stuffs. What kind of stuffs? Something of this sort. So you have point of sales, which is nothing but streaming data. It comes to your PubSub Dataflow BigQuery streaming job, or something from logs. You use data fusion, do some transformation, dump it into Google Cloud Storage bucket. Do want to do some transformation on it, use it. Or data fusion is using Dataproc, that could be something. Once it comes, you have your Looker platform, which is totally uh, an acquisition. So it's going to have its own um, querying layer, machine learning layer, all those things to visualize it and show some trendings, all those things. So this entire part which you see, this is a Looker component. And you will also have some SDKs. If you were to query some few things via programmatically, you can also do that. Or to have a connector, new connector to be built, you can do that. So that's basically where Looker comes into picture. So if I just show you, go to Looker. So big data, you see Looker. So click on it. It shows you this part, folks. A business intelligence and an analytics platform. And the pricing part, it was just a copy paste of the message which I saw there. So reach out to the sales representative. So they don't mention it very clearly. The reason is it's an acquisition. Maybe in future you may see a better pricing model, which is going to be very helpful for a cloud architect to decide whether this is going to be a good solution or not. But currently now you have to reach out to the sales. I guess the sales is going to be mostly the people who worked in Looker, same organization which was acquired by Google. So why I'm saying so confidently that it's going to become a seamless integration is when it was acquired in 2019, right? At the time, you were not even able to get a trial version of it. They were very specific. They never gave a trial version of it. Now, after Google acquiring, it's almost 2 years or close to 2 years, you see an option for trial. So you can use a trial version of it, try it. If you are happy, you can go for it, basically. So as a cloud architect, you should be aware of all the products. That's the reason I'm putting at least a couple of slides to make sure you are aware of this product. So what we'll do now is we look into the next important component. This could be really important from the exam perspective because there's a case study related to this one called as Theramirth case study. There, it's basically IoT devices. So if it's IoT devices, you should have some kind of a gateway to understand how these devices are sending data, understand it, ingest it, send it to PubSub, Dataflow, BigQuery kind of a stuff. So to get that complete picture, we need to understand this component called as IoT core. So we'll explore this IoT core, basically managing your devices and ingesting the data. So we'll talk more about this once we come back from a break. So we'll take a 10 minutes break, come back. Once we are back, we'll explore this. And this is very important. And this is the last piece which is pending to understand our Theramirth case study. So when we come towards the end of our training, so we are going to explore the 4 case studies. One of the case studies relies on this called as Theramirth. Okay, so let's take a 10 minutes break, come back and explore IoT core. Take a break, folks.
This conference will now be recorded.
So the importance of IoT, just wanted to give you some thoughts there. I guess most of you know it. So any device which can connect to internet is going to be an IoT device in very simple terms. And if you look into any statistics, usually you'll come to know the number of connected devices is more than the entire population of the world. That's statistics at which you see. And if that is the amount of data rate at which the devices are increasing, the amount of data it is going to send is also going to be massive. So you should have a system which can scale to that extent, uh, manage those devices when and all required. So what do you mean by manage? So very simple example, say for example, if you have a very smart refrigerator which can connect to your Wi-Fi, home Wi-Fi, how will you manage this refrigerator sitting somewhere in your office is basically where IoT comes into picture. So how do you do basically is you can do some analytics and then control it. Say for example, if your refrigerator, most of the refrigerator will have a specific panel or a placeholder where you keep a milk bottle. If the milk bottle is empty, you can have some kind of an analytics running. So the the embedded system which has in the refrigerator can keep on sending every 1 hour a screenshot of what's there in the rack, in the refrigerator rack. And based on that thing, if the rack is empty for the last 2 hours, it's an indication that something is not there. So you can try connecting this. So the milk bottle is not there for the last 2 hours. It's an indication which can trigger an SMS or a notification to order basically a milk bottle to a provider. It could be something like any big provider who provides online stuffs basically. So there are lots of stuffs like, say for example, bigbasket.com or anything of that sort, bigbasketdaily.com or something, where you can send a notification. You can have a system integrated. Now you see how the IoT analytics comes into picture. So just connecting to a device, I would say to some extent it would be helpful to control, to get some statistics, but running an analytics on top of it is the key part of it. Now, so now if a milk bottle is empty, is not there in the rack, you send a message to get basically to order a milk bottle. What if the entire refrigerator is empty? So this is where IoT core kind of products comes handy. It is going to manage the device, meaning stop the refrigerator, switch it off, power it off so that you don't consume electricity. It could be a possible option. So those are kind of stuffs which is going to help you manage the device also. So those are where this product comes into picture. So I don't have the equivalent of it, but today we saw there is a recent article, right? So the comparison, we can quickly see the comparison of that in Azure and AWS IoT. Okay. So in AWS, they also call it as IoT Core. In Azure, it is called as IoT Hub. So maybe I'll update my slide soon. So you have a equivalent available in other cloud also. And per my understanding, the AWS IoT Core is little sophisticated because I have went through one of the problems with IoT GCP IoT Core, and I'll share you that information also. And when you are deciding to work with IoT Core, what are some important points which you should consider also? I'll share you with that. So first of all, what is this service? A fully managed service that allows you to easily and securely connect your device to GCP ecosystem. Manage. I really like this part. The manage part is very, very important. The example which I mentioned. So if the entire refrigerator is empty, why do you want to keep the refrigerator running? It is of no use, right? Switch it off. Or if it's a vehicle where it is going to send some telemetry data, and if the vehicle is not at all moving, why do you need to keep the engine on? Stop the engine. So that kind of a stuff. And also ingest the data from those devices. So basically it's going to act as a gateway. Why you need this kind of a stuff is basically multiple devices will have different protocols. Not every device is going to use the same protocol. Now if you take it as a single the population, so every people talk different languages, so there should be something which is like one single place where you can understand all their languages and make sense out of it. So a gateway kind of a stuff is very important. That's where this IoT core comes very handy to easily connect, manage, and ingest millions of information. And this service is totally serverless. So meaning you don't need to worry about the infrastructure itself. You just go create a registry, more like your yellow pages, where you are going to have entries of telephone number of various users. You're going to register uh, various devices in a registry, IoT registry, and you connect to it. Basically, that's it. And because it's IoT, protocol is very, very important. What are the protocols supported? Currently, it only supports two protocols, MQTT and HTTP. Uh, Very limited number of protocols, but if you see AWS IoT core, they support more more protocols. Now this protocol was a problem in one of the projects which I did, because of which the project was extended almost for 3 months, folks. 3 months. So that's where I realized that whenever next time I do an IoT core project, the first and the foremost question which I should ask them is, what is the device, the protocol the device supports? So it's worth putting it in the implementation documentation. Any IoT use case, first ask the question, what is the protocol the device which needs to be connected support? What is the protocol the device, what is the protocol the device supports? I'll just mention it. Device supports. If it is MQTT or HTTP, then Cloud IoT core supports. But in my case, right, I did not do the initial the things. There was some other person actually. Most of the projects which I have done, the benefit which I have got is uh, some architect would have done it. There would be an issue. Because of that issue, they come to me. So that kind of a stuff has happened. So that helped me a lot to understand what was a mistake the other architect did. So learning from the mistakes. So that was an added advantage which I got. A few projects came to me like that. So the use case where I told it was extended to 3 months was, it is basically a low-end device, low power devices. So it's not like our phone, our laptop, which is a high-end device which can send good amount of data using standard protocols like HTTP. So the device which I had, the devices which we were supposed to do is, if the protocol is like Modbus, you can just search for it, folks. It's a protocol, usually with IoT. So if I can search it quickly, Modbus protocol. So this is basically for IoT purpose, and this is a little older protocol. So this is not supported by GCP, and I'll show you that in the demonstration when we do it. Modbus AWS IoT Core, they support it. They support it, and you can go use it. So there was a situation where the customer literally thought of switching to AWS. We had to write a small Python module which converts or reads from Modbus serial port and pushes to IoT core. We had to do that kind of extra work, which was more of this. The 3 months delay was because of this development process. So some architect don't ask the requirement completely, and which is going to impact the deliverables. So make sure the protocols which supports are verified first itself. If you it is not there, you say upfront it's going to take more time, or maybe the customer itself will drop off. That's okay. Instead of having extending the deliverables, delaying the payment, all those things, better say upfront. They will definitely appreciate sometimes. So later they may come back to a requirement where GCP can be really helpful. Or if you are an organization who works on multiple cloud, you can say GCP is not a good fit. AWS is a good fit if your protocol is going to be Modbus only. So that's very, very important. And how does the architecture look like? Basically with respect to your IoT core. So IoT core is going to be your gateway or the front facing GCP service for any devices to communicate the data, send the data, get controlled, all those things. Basically, uh, so you can have any device which is connected to internet, like a tractor, a wind turbine, a refrigerator, anything. It sends telemetry data to cloud IoT core, and the protocol supported is only as of today MQTT and HTTP, only these two protocols. Now this is going to be more like uh, uh, a hub which can get the data ingested, but it cannot retain the data for a longer time. So it needs to have a staging environment. So the best friends or the thick friends, I would say, IoT core and PubSub. These are thick friends. So without PubSub topic configured, you cannot create a IoT core registry. So you need to have the streaming data staged in PubSub. Now you really see the value of PubSub. So any streaming data comes, you can stage it in PubSub for maximum how many days, folks? What's the maximum we can store? How long we can store it in PubSub? Maximum? Any thoughts, folks? Huge amount of data is coming, millions of information. So it needs to be, sometimes it is going to be too much. Yes, Aman. So it's going to be 7 days. So what if that huge amount of data is going to crash your downstream applications? No problem. It can be staged in PubSub for maximum 7 days. So your downstream application can be fixed within 7 days so that it can come up, pull those message and do the remaining processing. So that's where this PubSub is going to act as a staging environment. It's only 7 days, folks, not 7 days to 365. It's only 7 days. The maximum is 7 days only. So your PubSub is going to act as a staging environment. Once the data is in PubSub, definitely because it's a streaming data, our cloud data flow is going to come into picture. Then you transform it, do some transformation, put it into your BigQuery. So basically, from IoT Core, PubSub, Dataflow to BigQuery, and if you want to visualize something, use your Data Studio or the previous erstwhile Datalab or your AI platform notebook, where you can write some graphs also. Python supports you that. So that's what you see basically, and you see some additional components here like big table, machine learning stuffs. I'll explain, and cloud functions. We'll talk about that in a minute. So this is going to be the typical flow for an IoT core, and the same architecture is what we are going to see basically. So 1, 2, 3, 4, 5. So this is a component which you can use in a case study called as Theramirth. So very important, and we are going to re-emphasize, or we are going to look into this architecture one more time during the case study time. So now you see here, folks, big table sending to BigQuery. This is the external table concept. So if you want to do some kind of an analytics streaming insert, but it's going to go into, because it's IoT, right? If it's IoT, the best fit is always a cloud big table, CBT. But if you want to run some BI stuffs, you see there's no stuff related to data big cloud big table. You have to use it as an external table in your BigQuery, uh, then connect it to your data flow, or sorry, data studio or data lab. So it's very, very important you use this as a querying layer, your big table, very important. So that clears why cloud big table came into picture, because it's IoT use case. You dump everything with the lowest latency in big table. But if you want to do some dashboarding and all, you have to use BigQuery. Now, any reason why you see, I'll come to cloud functions in a minute. Now, all the historical data will be stored in BigQuery. Now let's take an example of a tractor, folks. On an farm, on an agricultural land, you have lots of tractors running, and tractors are sending telemetry data, assuming that these tractors are equipped with 4G or 5G kind of cellular connectivity. So it's going to send n number of telemetry data. It comes to IoT Core, PubSub, Dataflow, then either go to big table or directly get inserted into BigQuery, either one of them. You will have about one particular tractor itself, you will have lots of information, telemetry information. This telemetry information is going to be a good fit for machine learning. It's going to say whether the tractor is used effectively, how frequently the clutch plate is pressed, how frequently the brake is applied, is the engine oil up to date, is what is the level, what is the piston, how the piston is working inside the engine. You can get all those kind of telemetry information. Now historical data is there. If there's an historical information, you can start predicting whether the tractor is going to go down for a maintenance. Is the clutch plate going to be damaged in the next 20 days, or the engine oil needs to be changed in the next 30 days. You can do that kind of a machine learning stuff with the historical data using a component in GCP called as machine learning engine. So the data is very, very important. You already have the data, petabytes of information in BigQuery. You apply those machine learning. Then once you have the machine learning, you should communicate this back to the device. So that's where you are going to update the configuration. So maybe the idle time. So everybody uses a vehicle. So if you turn on the engine, and if the car, if a bike or anything, it gets stopped immediately, the idling period is short. So if you want that kind of a tuning, maybe you can do it. So every time starting, and if you start the engine and if it's not moving in the next few seconds, if it stops, the idle time is not set. So maybe that kind of understanding you have got it. You want to update that setting in your device. You can do that. So that's where you see a red color arrow, which is basically updating the device. That's good. So cloud functions also can update the device is what they are saying. Now, can anybody tell me what could be the possible use case of a cloud functions? You know how cloud functions works. One of the possible trigger point is going to be a PubSub. So PubSub cloud functions update, send it to the device. What could be the typical use case, folks? If you take a vehicle into consideration itself, where you can update it. There's no machine learning here. There's no machine learning here. But here with BigQuery, you have the historical data, you do some machine learning and then do it. This is a hard and fast kind of a rule is what you're going to apply. Any possible use case, folks, which you can think of why cloud functions is put? Any thoughts? I have one option, but I want you to think first. Any parameter optimization, which does not require any machine learning stuff, any machine learning stuffs. So possible, Vivek. So no machine learning. You just want to have a hard and fast rule kind of a stuff. You can put it in cloud functions. Good. Anything else? One possible option which I can think is now the same data is sent to Dataflow also. Data cleansing from data cleaning from IoT device. Not very sure what was that. Data cleansing. I don't want to cleanse anything because the data cleansing is going to happen in your data flow. If the tractor is not responding, yeah, that could be a possibility. If the tractor is not responding or something, you do some changes. That could be a good choice. But data cleansing in this architecture, at least, Vivek, data flow is going to handle it, not cloud functions. Uh, uh, One possible use case is something like this. Assume the engine is on. Assume it is like 1 o'clock in the afternoon. Uh, the person who has started the tractor has just left the tractor on the farm field without switching it off and went for a lunch. The engine is on. And assume typically humans take 30 minutes for lunch. The engine is running ideally for 30 minutes. Uh, Now, the same data is going to say engine on for the last 30 minutes. It is going to go to data flow that captured in BigQuery, but you can have a small logic. Engine on for the last 30 minutes. You can do some kind of a logic in your cloud function. This does not require machine learning. A small program in Python, Java, .NET, anything is going to be possible. You just write that logic and update the device. What is the device? Turn off the engine. Simple. So which does not require any machine learning. So something of that turning off the engine with a specific hard and fast rule is going to be a good choice for cloud functions. So now you see lots of components used. Lots of components used. So what we are going to do in the next few minutes in our demonstration, we will use this flow, folks. And we will have a simulator. So we will have a simulator because we don't have a tractor. We'll use a simulator and send it. Um, so there's one information I checked and found AWS supports MQTT and MQTT over WS and HTTP. Okay. So what I mentioned was AWS supports Modbus, specific use case which I had. So MQTT and MQTT definitely is going to be supported. These are standard, but they support more is what I wanted to say, Vivek. So if it's going to support something like MQTT over WSS, that's also a good choice. So you have more possibilities compared to GCP. So maturity wise, I would say AWS IoT Core is a good choice. Now we'll do a small demonstration on this, which could be really helpful for our Theorem Earth case study. So, And if you are really amazed by IoT core capability, and if you want to give a try, do it yourself kind of an option, you can use this feature called as monitoring home appliance. This is an article which Google launched. If you just search it, you should be able to get it. Smart metering. So data from smart meters come. So these are kind of small stuffs which is implemented in many places in Japan and all. So our utility bill, the meter which you have, the electricity meter, you understand it, and based on that you do some smart metering there. So the data comes from the meter to IoT core PubSub. After IoT core, the next component has to be PubSub, folks. If you forget to put PubSub, you have not done a great job as an architect. So these are two components which you cannot separate. PubSub can live independently, but IoT core cannot live independently, basically. So that's the important stuff. So after PubSub, you do a app engine. Any reason why app engine is here, folks? What could be the possible use case of app engine? Any thoughts? We are cloud architects, which definitely should have an answer for this. Uh, so any thoughts, folks? Why app engine was put here? Basically, if you go back to your PubSub subscription, there was an option for two types of delivery. One was a pull and the other was on a push. And we had seen the push could be a possible choice for a push is a app engine, right? You basically you push the topic, then you send it to machine learning, do some training, do some predictions, or you send it to another PubSub topic, or maybe to BigQuery. So basically, it is the reason it's basically a subscription. Here, the indication is it is basically a push delivery type. So yes, so and because push is the one which is recommended in production. Basically, that's the reason. uh, if you want to implement this, folks, the entire source code is available. You can go look into it and you should be able to implement if you want. So that way you'll learn IoT core, PubSub, app engine, BigQuery all together. Good option. And they use something called as Colab, which is somewhat equivalent to your Jupyter notebook, so to develop any logic and to visualize it. So now what we will do is, we have solid 1 hour. We can do this demo completely today, called as IoT core. The whole reason for doing this demo is Teramat case study. Okay, so let's do it. And if I go back, we had done a demonstration where PubSub, IoT core, BigQuery was already there, streaming demo. Now we are going to add IoT core and a simulator in front of it. So this time when we do this, we are going to use some best practices of best practices of our IAM and all. So data flow, we are not going to use the default service account. We are going to create a service account which should be able to read from PubSub, write it into BigQuery. That kind of a IAM role we are going to use for a custom service account. We are going to have data flow. Last time when we created data flow, it was using external IP address. We will not use that. We will use only internal IP address. What is the fun in having an external IP address? It's going to be a cost. And it's all internal communication only from PubSub to BigQuery. Why do you need to have it? So we are going to turn it off, external IP address, use a custom service account, then those two things we'll try to do as an enhancement. And I'll show you how the simulator also works. Okay, so first and the foremost thing, uh, let's provision our IoT core. So for this, I'm going to use basically my GitHub page. So the code is in the GitHub page also. Git github.com/. So it's Teramonth. Why I'm using this is it has a simulator, so you can use a simulator and do it. It's written in Node.js, so we're just going to use this data and do it. So I'm going to clone this also. First, I'll fix the simulator. We'll do it later. First, we'll have the IoT core provision, and we'll also see when you're creating the IoT core itself, PubSub details needs to be mentioned. So you'll see that part. Let me go to my, I'll close all the stuffs. So go to my IoT core, which is also going to be a component in our one of the services in our big data category, IoT core. Again, the API may not be enabled. We have to enable it. So enable the API, register and manage your IoT core device. Enable the API. Okay, the IoT core is enabled. And what we are going to do is create a registry, as I mentioned, because it's going to be more like your yellow pages, an entry of all the telephone. Now it's going to be an entry of all the devices. So let me create a registry. So I'll call this as batch 6 registry. And another drawback of IoT core, it's only limited to only 3 regions, folks. It's a regional resource, but it's only in one in each continent. 25 regions we have as of today, but it is only in Taiwan, Belgium, and US Central. So yet to have more presence. So I'll add it here. It's a regional resource, limited, current, only available in 3 regions as of today. So we will use, let me use US Central itself. Anyway, I have my data flow. I can create it in US Central because of my this thing. Now, when you create that IoT core registry itself, it asks for PubSub. So, routes the device message to PubSub for aggregation. You can route to a different topic and a folders, subfolders in PubSub. You can have those logics. So specifically, there's a question. This is Taiwan, Vivek. This is Taiwan. Taiwan, Belgium, and US Central. Only 3 places. So if you were to do something in any other parts of Asia or any other parts in Europe or US Central, may not be a good choice actually. Currently, you have lots of limitations there. So protocol, number of regions is definitely a limitation here. So I'll use US Central. You have to have a PubSub topic. Without a PubSub topic, I cannot create a this thing. It's of no use basically. So let me create a topic. I'll create a new one, folks. I'll call this as what we'll call it as batch 6 batch 6 underscore IoT core. Done. I'll make this as batch 6 underscore registry. Good. Now, if I click on advanced option, this is where you will see the protocol supported, folks. Only 2 protocols, nothing else. Nothing else. If Modbus was there, the 3 months would have been easily saved by us, but we were not able to do that. So do it. And by default, this is very important. The logging is going to be disabled. The only reason is millions of information is going to be generated, inserted. If you turn on logging, your price is going to shoot like anything. So be very cautious when you want this, and you can turn it on, turn it off whenever you want it. So by default, it's going to be no logs captured. So then you have some certificate stuffs which you need to basically add. So I'm going to just leave it as empty for now. So what I have done, basically gave a name, selected the region, created a PubSub topic. Then the certificate, we will generate it soon. For now, we'll just leave it as default, empty. Click on create. So by the time it gets created, I'll try to open the cheat sheet so that you should be able to see it. Just give me a minute. I'll get the cheat sheet so that we can. So there's some syntax which I don't remember it to generate the certificate and all. So let me just get the this thing so that it's also easy for you to follow when you want to do the demonstration. Uh, so IoT core, this one. So you create a topic with this name. We have created it. Now, what we will do is the registry is created. The registry is created on which protocol your project. I have turned on both, Vivek. I have turned on both MQTT and HTTP, both. So both are turned on. If you want, you can edit it always. You can always go back, edit it, which you want. I have turned on both. And the demo which we are going to use is going to use MQTT. So if you don't want HTTP, you can turn it off. You can turn it off. So what we will do now is we will register a device. So we are going to register a device. So whenever you are registering a device, definitely some certificate has to be generated. So let me click on devices. So registry is there, meaning a yellow page book is there. Inside that you have to add an entry. So meaning you need to purchase, you need to get a telephone connection. Similar like here, you need to create a registry here. Uh, the device is the thing that connects to the internet directly or through a gateway. So we are going to directly connect it using the simulator. So click on create a device. So I can give a device name as tractor. That's the device. So tractor device one. Maybe there are n number of tractors. So I'm going to make it as tractor. So the options which you can fill in here is whether you want to allow this device to communicate or it should be blocked. So this is a good option. You can block it. So when to block it, I'll also show you the demonstration once we finish the demo, complete set. And logging, it's going to inherit what you set up in your logging part. So if you have enabled there, it's going to be enabled. If you have disabled there, it's going to be disabled. Or you want to override it, you can do it. Then the authentication part. So now the device has to be authenticated. So for that, you have to enable, there's a question, not just the project reference you gave. Okay, in my project reference, sorry, I did not see that question. Wait. So it was Modbus was the one. So we had to change that Modbus to MQTT, then use MQTT. So because Modbus was not supported. So coming back here, you have different ways of having sharing your public key. So I'm going to use RS 256 X509 option. Now you have to generate a key. So you can use OpenSSL to generate a public key. So I'm going to use that command which is there in the cheat sheet. So this is the command which I'm going to use to generate my key. Copy it. I'll use my Cloud Shell. and we need to paste that key here. So what I'll do is I'll create a folder called as IoT core. So currently it's an empty folder. When I run this command, it's going to generate me a private key and a public key. What I need is this public key details to paste it here. So I'm going to use a cat command. This is my public key. Copy it completely and paste it here. Good. And you can mention expiry date, all those things if you want. I'm going to do it as don't expire. So this is the way I should be able to register it. So when I'm sending any data, right, my device should have that private key. So the private key, public key option is going to authenticate and I will be able to access it. So now let me click on create. So the device gets registered. So the device is registered, but no information has been sent. The device never communicated with our IoT core or our registry, basically. So no configuration sent, but authentication is done. So everything is good. Now the first part we have done it basically. Now you have to make sure the data is sent. You register, see whether the device can communicate. So let's do that part. And what we are going to do is we are just going to send simulate the data and send it out. So for this, I will clone. I'm in this current working directory. So what I will do is I'll clone this code. I just clone this a small piece of code, git clone, done. So if I go inside this, basically it's a Node.js application. If I open it and show you, it's an existing code. I just modified it. If I go inside IoT core, Teramath, edit, Teramath.js, a code which just simulates as if like some telemetry information about the volume, the pressure of the tire, that kind of a stuff, just simulated one. This is the stuff, folks. What is the device name, device ID, pressure, the speed, the engine uptime, oil, timestamp, because I want to track every details. So I'm generating this kind of a simulated stuff. Basically, when I run the simulator, it's going to generate these details, basically. So the top, these are basically fixed. Now I have a drag line, which is a kind of a device. So I'm going to make this as tractor. Tractor 1. That's it. That's my tractor. What is the pressure? The tire pressure, speed of which the tractor is running, the uptime of the tractor, oil level, and what time this data was sent. Basically, this is what I'm going to do. So because it's a Node.js application, there's going to be some dependencies for it. Make sure you do npm install. So when I do npm install, some of the necessary packages is going to be installed. So currently, if you see, there's only 2 files. So I'm going to install the packages necessary for my code to work. It's going to find, install everything. All the details are mentioned in package.json. Done. Now if I put ls, you see this folder, folks, which is going to have the necessary modules to do all the stuff. Now you just need to execute it. There should be a command in the cheat sheet, equivalent command, which we need to slightly modify it. Yes, something of this sort. So you should have a this thing to check the details. Now, one important thing which you need to do is you have just created a topic. The topic does not have any subscription, and we know if a topic does not have a subscription, the data would be immediately deleted. So make sure the topic is having a subscription. Just check it. Then you should be able to run this code. Let me just check whether it has the PubSub topic which we created has basically a subscription created. It should not be there. Let's verify it. I'm going to delete this. We don't need it. So this is the one. If I click on this, it says there's no subscription. So you have to create it. So let's add a subscription. Let me call this as batch 6 IoT core sub. And I'm going to leave everything as default. It's going to be a pull. All things I'm going to leave it as default. Why this? Because when we simulate the data, it should come to the topic. And if you don't have a subscription, it's going to be immediately deleted. So we wanted to see the data, the simulated data reaching PubSub. For that purpose, we are creating it. So it can be staged for 7 days. Now it is there. Now what I'm going to do is basically run the code and execute it. So, and the way you run this is going to be something of this sort. I'm just going to copy this content, do some slight modification because we changed lots of stuff. Project ID, yes. The region is going to be US Central. That's where your registry is there. US Central 1. What was the name of our registry? It was something different. Name of our registry is batch 6 registry. The name of your device is tractor 1 device 1. Good. And you have your private key. So I'll copy it. 25 messages I want to send it. So this should work if things are all fine. So what should happen is you should see the device telemetry received information. Currently my time is 11:42. So it should show something of that sort. When I send some 25 data, 25 informations, 25 messages, it should show that stuff. So currently it shows nothing because we have not even communicated once. So what I'm going to do now is I'm going to copy my what is that private file here into my what is that Node.js for this thing application running. I'm just going to copy this line also, change this. So this is the code name. Simple. Node.js therema.js. The other details, project ID, what region, what is the registry, the private key file, all those things. If things are all fine, it should run. It should start simulating it. So for to start with, I'll just make it as 5 messages, folks, just to see if things are working fine. So hit enter. Okay, it is sending the information. After 5 entries, it's going to stop. Connection closed. Now let me verify by refreshing the screen. It should show these details. Now, if I refresh it, Good. Now you see the time is 11:43. So the telemetry information was received. Good. Configuration was sent. So I am able to communicate. There is an error. The connection was broken or closed by the client. That's fine because we just stopped it. So at least we have got the data from my cloud shell. You can treat your cloud shell as a device. It is sending data. It has reached my IoT core. The data was received. Now, if I go to my PubSub subscription, view the message, those 5 messages which you sent should have been received here. Awesome, folks. You see those things? So this is the information which you have sent. Now, if you compare it, it was device tractor 1. So pressure was 006. What was that information? If I just close this, the first one, that was the first message. So now the data is staged in PubSub subscription, the PubSub. Now you should be able to pull this using your data flow, do some transformation because it's already in a JSON format. You can do a transformation and insert it into BigQuery. Now what we will do now is we know the type of data which is going to be coming. So what I will do is copy this, go to JSON validator, create, understand the data, and we'll create basically a table in BigQuery which can handle this. Registry is string, device ID is string. This is also device name is also string. This is going to be a float or numeric. We'll make it as float. Speed is integer. Uptime check engine uptime is integer. Oil level is integer. So only one is float. We'll just create a table like this, and we should be able to insert it into BigQuery. Let me do that. So connecting the pieces, and we'll use the same data flow template which we used, uh, PubSub, Dataflow, BigQuery. The same thing we can use it to insert it here. So I'll go to my BigQuery. BigQuery. I'll create a table called as empty table. Let me call this as what to call IoT core. IoT core. Now add your schema. So now we know the schema: registry, string, device ID, again string, device name, string, pressure. I'll see whether I can make it as, I'll put it as float, speed, integer, engine uptime, again integer. This is a timestamp. So oil level, okay, integer. The last one is a timestamp. It goes as timestamp only. That's it, folks. So I guess we have all the details. Pressure, speed, uptime, all these things are there. Good. So if you want to make it as a partition table, go ahead and do it. Anyway, there are lots of fields which you can partition it, or if you want to partition it by timestamp also, you can do it. So by an hour is a better choice because we are going to send at an hourly rate. Every second we may send. So I'm going to make it as a partition, this thing, and also put a where clause, the filter. So what and all we learned, we are trying to put it in an implementation itself in our class itself. That's a good part. So an empty table with these many attributes or columns, And we are also turning partitioning. We are making it more sophisticated demo here. Any advanced section? All good. So that's it. Click a create. It's going to be an empty table is what you are going to create now. So it's a partition table, but it's empty currently. Now what I'm going to do basically is go to my data flow and create a new job to use the new PubSub topic, which is IoT core something which we have created, and insert the transformed data into IoT core in BigQuery table. That's it. Should be all done with that. And we'll again simulate once the data and you see how the data gets inserted. So let me just do that. Go to data flow. And we'll do some slight fine tuning here. So first, before I create a data flow, I'm going to create a service account back to the first days, the beginning days. So I'm going to create an IoT core PubSub Dataflow BQ. That's the this thing, name of my this thing. Create it. What's the role which I should give, folks? The data flow should be able to read, at least we are not going to do update because we don't have machine learning stuff. So the data flow should be able to read from your PubSub topic, some kind of a PubSub reader or something, and write some data into your BigQuery. So you can make it as you need to write data. BigQuery user role could be a good choice, or BigQuery job user with big or something like. To start with, we can just give it as BigQuery admin. If you want, you can still fine tune it. So at least instead of using a default service account, we are using some predefined service account. So I would strongly suggest you to still fine tune it because if I fine tune it fully, you'll not have interesting stuff to do it yourself. So go to PubSub. PubSub, you have lots of roles. So publishes a message. So viewer, view the topic, this thing. So a viewer role should be good enough is what I would feel. Get it? See if you can still further fine tune it. And I should be able to read the subscription, all those details. Then BigQuery, I should be able to insert it into it. I'm not going to choose the least privileged one. I'm going to use admin. I would leave it to you to figure it out what should be the best role you have to give. This is not the best role, but it's acceptable role. Continue. Done. So that's the service account which we have used. Now this is a service account which we are going to put it into our uh, data flow job. And what I'm going to do also is some networking stuff is also going to come into picture. So we will go to our data flow. Data flow jobs. So I can use the same job, clone it so that most of the details can be filled in. Clone it. I'll make sure this is the job name. I'll put IoT core PubSub Dataflow BigQuery, and I will run it in US Central. PubSub topic to BigQuery is the template which we are going to use. What is the topic name? The topic name is, let me get it in the other tab. So there's a PubSub topic name. Let me copy it, change it. That's good. What's your table name? Go to your details. You'll get the table name. I don't have a bucket like this. Let me create a bucket because I deleted all the buckets. So let me just create one quickly. I don't have that. I will do it with the same name, but make it region US Central. Click on create. So far, this is the same thing which you did last time also. Now, definitely we have to do slightly modification, right? Doing the same demo again and again is of no use. So let's try to do some modifications. These are all standard. So the now modifications which we are going to do is basically, I'm going to have only one worker node. We don't want two. One is enough. The region, we want it to be very specific. The zone, you can change it. I want it in US Central, specifically in F zone only. That's my requirement. Service account, if you don't mention it, it's going to be the default service account, and we don't want that. Last time we used this. We did not mention it, it used the default service account. Now this time we are going to use the service account which we created now. So we may have some IAM roles issues, something. We need to fix it also, but let's see whether it's going to work or not. But it's really a good improvement towards our stuffs. So that's good. The machine type. Last time we just left it as is. So it took N1 standard 4 for streaming. So you can leave it as is if you want, or you want to explicitly mention, you can do it. So, but streaming should have better compute option. So let's leave it as default. Now, this was the first change which we did. First change was specifically a zone, saying that F zone is what we want. Machine type, we have mentioned, sorry, service account, we wanted to mention a custom service account. That is also done. Second point, this is important stuff. We want to basically use a private IP address. Only use private IP address. So allows data flow workers can be configured to use public or internal IP address. So if I make it as internal IP address, if I go back, data flow, a managed instance group, should be able to read from PubSub and write it into BigQuery. So now it has to use internal IP address behind the scene. What could be important here to turn on in my networking, folks? Everything should happen on internal IP address. Virtual machine writing to a BigQuery stuff. What is that which you need to turn on in your networking, in your VPC or in your subnetwork? Two services. Now the service account details, we have mentioned it, but two services, they have to interact each other. One is a virtual machine, the other one is a BigQuery table. What is that extra thing which you need to do here from the networking perspective? Things are going to work or you have to do something extra? If you don't know, we'll just leave it. We'll see if the error comes up. Okay. So if you know it, let me know. We'll do it right away. But if you don't recollect it, we are just going to leave it as is. Anybody has a thought on in the networking part? So this is all connecting the stuffs which we have done, folks. Firewall. What is there to do with the firewall here? PubSub, you are reading it from, so it's going to be an incoming request. So now you want to write it, it's going to be an outgoing request. But what IP should I put? I'll not have a details of my IP address. So it's all internal. So it's all internal communication. So if you remember, we had done something like a virtual machine writing or getting the details from a Google Cloud storage bucket. using internal IP address. We had turned on something. If it is external IP address, you don't need to do anything. But if it's internal IP address, there was a setting which you had to do, a Google Cloud Storage and a BigQuery. How it's going to interact using internal IP address, folks? That is the same thing which you have to do here also. No. Private Google access is what you should turn it on. So you have to turn on private Google access. Then things may work. So things may work. So if I click on, let me fill this form. When you do it without doing it, it's going to throw an error. Maybe we can skip that message, this thing. So if I click on this subnet, two services, your private Google access is turned off. From a virtual machine, you want to write it into a BigQuery, that using internal IP address, meaning private Google access should be turned on. If you don't turn it on and try to run the job, it's going to throw an error. Private Google access not turned on. So we'll turn it on. So you see lots of features we are trying to recollect by doing this demonstration. Turned it on. You can give a try without turning it on and you'll get that message. So to save some time, I'm going to do this way. Turn it on right away. Go to my this thing. So all good. All good. So what are the changes which we did? We are using a private IP address. We are using a custom service account. And we wanted a virtual machine, one virtual machine only in a specific zone. Let's see whether things are going to work or not. Run the job. Go look into it. Let's wait for the job to show up. Okay, it is already throwing an error. Permission. Okay, this is the real thing. So now you see it. Let's expand it. I would expect your help here, folks. So what is this? Permission verification for the control service page. IAM should be granted. Okay, what is this role, folks? Now you see, if we had always used default service account, we would have never got to know that the IAM, the service account which you create should have data flow worker role. So now we learned it. Let's go ahead and give that this thing. So along with the roles which we have given for read and write, it should also have basically the data flow related role is what it is telling, which is really a valid one. Let's go ahead and give that data flow worker. Data flow D. Data flow worker. Good. So a new learning. Done. Now the beauty of data flow jobs is if something is wrong, you don't need to fill it again. Just click on clone. Everything is going to populate except one thing, which is a bug in the UI. Oh, two. The regions are not set. We'll set it in F zone. Service account is also set or not? Oh, service account. Oh, service account is set. IP address usually becomes unspecified. I'll make it as private. So what you should expect if things are all working fine, a virtual machine with internal IP address, a virtual machine with this service account running. Basically, that's what you should see if things starts working as expected. So the job is running. Let's see whether it runs this times correctly. The same kind of DAG which you saw should show up. Again, throwing an error. Okay. Workflow step, setup of the resource, creating PubSub topic, user not authorized to perform this action. Workflow setup resources failed. Something looks like something related to the service account role which you are giving. For simplicity reason, I'm going to make it as PubSub admin. I would give it as a small assignment for you to see what is going to be the best uh, least privileged role which you can give. In the interest of time, I'm going to make it as PubSub. Viewer is not going to be a good choice. I guess publisher should be the one. Let me make it as admin so that I should be able to read the topics. Second time, so third time we are going to do, so it has failed. Now you see the real problem, folks. If I, is it really working or it's, it is working. That was a previous error. That's an error. Now at least it should have been fixed. It's a warning or error. Okay, let me stop this job, folks. Let me stop this job. Or before stopping it, let me see my virtual machine. Is there a virtual machine created? That way I can have some idea things are working or not. Virtual machine running. External IP address is none. Beautiful. If I click on the virtual machine details, the service account is good. And you see lots of startup related stuffs or metadatas, folks. These are all the stuffs which you see. They're using a virtual machine for the real implementation. So data flow is running. We'll give a try, folks. We'll give a try sending data, or if you feel, let's just cancel it and give a try. We will see whether giving PubSub admin is going to resolve this error or not. This error, it's going to error remote or not. Let's see it. We have 40 minutes, 20 minutes. We should be able to do it. It's canceling. Let's just wait for a minute. The whole thing which we are going to do is once the setup is ready, what we are going to see is IoT core is ready, PubSub is ready, and the simulator device is ready. Now what we are doing is PubSub, IoT, data flow, and BigQuery. We are making it ready. Once everything is there, you just start sending the data. So it should flow from IoT core, PubSub, data flow, get transformed, get inserted into BigQuery. And if you want to visualize, you can use your data studio to visualize it. So let's see whether it's going to come up. It's canceling. So when it is canceling, the instance should go off, basically. I'm waiting for it to cancel. Okay, it is canceled. Now click on this. I'll do the clone again. This cloning is really helpful, folks. It was not there in the beginning, so it was very difficult to fill in the form every time. So now they have added it. That's really good. So let me use US Central F1. Service account came properly, unspecified to private. All good. The next time, hope it works this time. You can verify whether a VM has been created or not. Not yet. Let's wait for the job to start running. it shows currently this part. This piece keeps refreshing. So okay, spinning up. Once it is up, you should see one vCPU, something of that sort. Sorry, four vCPUs. It is four vCPU. External IP address is still none. Let's just wait for it to come up. If there's no error, there's no error, folks. There's no error. It's all good. Now you see four vCPU. Now what we are going to do is send the data. So 5 records I'm going to send. If everything works fine, it should reach my BigQuery table. It should reach my BigQuery table basically. So I'm going to use schema like registry ID. And I'll put, yeah. So if I run it, it's going to show basically 0. No records are there. I can also make it as less than or equal to today's date. So it still gives 0 because there's no record. Now the time has come to send the data to my IoT core, which is going to update the time to 12:10, something of that sort. Then it should reach to PubSub, from PubSub to Dataflow to BigQuery. Let me run the simulator. For now, I'll just use 5 and I'll show how we can do it for more. Just change that number. That's it. So I'll just run this command which we ran last time. So 5 messages only. Send it. Last time it just hit data cloud PubSub. Now it should go to Dataflow, get transformed, and it should be also inserted in BigQuery. So if I go to my Dataflow, the same thing. Just click on the first DAG. Look for this number of elements added. It should show like 5. It should show as 5. Let's see whether it's going to pick it up or not. And we also know this Dataflow job is going to create its own subscription. It's not going to use the existing subscription. It's going to create a new subscription to that specific PubSub topic. So if things are all fine, it should show 5 soon here. 5 messages is what you have sent. Let's wait. There's a warning message. If you want, we can see that. Maybe it could be something to do with the quota, but that's fine. Still not there. But first, let me see whether it has reached my this thing. What is that? My IoT core. Let me just refresh it. It should show around 11, 12, 12 or something, or 12:10. That's how you can see the debug. Yes, the device has last seen. It also shows the last seen stuff also, this thing. That's good. Let me see whether it has reached my, not yet here. So can I see it, my PubSub topic? Go to subscription. This is the one which was created by your Dataflow. Here I can also see it. Let me see whether I can pull those new 5 messages. Has it come till here? We just need to verify it. Sure, totally 10 messages should be there. Only 3. Okay. Yes. The one which was sent at 12 o'clock, 12:10 is there. So it has come till PubSub. It's just a matter of Dataflow getting it and doing it. So awesome. 5 messages are read. It took time initially. So 5 messages are done. So it should have read it, transformed it, and if I go to my BigQuery and run it, it should show me 5 records. Awesome. So the data which you sent is visible. So this is the data which you sent. engine speed 7, oil level 3, speed 7, engine uptime 3, time is, it shows very correctly. So the data is now completely inserted into BigQuery. Now you want to explore it in Data Studio, you can explore it in Data Studio. And this is also partitioned by timestamp, which is really, really good choice. Now what we are going to do is we are going to send some huge amount of data, 100 messages. We'll see what is going to happen. And we'll also see how you can manage the device. What we saw is basically ingestion of it. Sometimes you would have heard of many stories with IoT, because these are going to be on a device where the networking or the security may not be great. So in that scenario, you should be having a capability of controlling it. You would have seen many stories like somebody used the IoT device to enter the network and compromise and do all the bad things there. So how you can find such things, and if you feel the data from this device looks like compromised, I want to block this device, how do I do it, is what I wanted to show you now. At the same time, sending a huge amount of data. So what I will do now is I'll go to IoT core here. IoT core in this page. The only reason is the terminal is there, so it's going to be easy for me to show you the demo. Now I'll go to this device, folks. To this device, the device was last seen at 12 12:10 my time. So now what I'm going to do is basically I'm going to use this option, send command, block communications, all those things. Now to show you that, I'm going to generate the data around 50 data telemetry information, so that you will see how I can control it, block it, all those things. So I'm going to run this. So you will see the telemetry information. Let me send a hi message. Hello, tractor. So this is a message which I can send to my device. You see this, folks? Hello, tractor. I can send a message. That's really good. Now I feel, if I feel this device is compromised, I can block it for a while. So now if I block it, what's going to happen? The device will not be able to publish it. So you see it, it is throwing error because you have blocked it. You have blocked it. Only if you allow it, then it's going to communicate. So if you feel no, this is not compromised data, it is really sending huge amount of information, allow it. One more time, if you allow it, then the upcoming messages are going to reach it. The data is going to be lost because you felt it was like maybe fishy, you wanted to block it, but later you found it's not fishy, you allow it back. So this is how you can do control the device basically. Now if things are all fine, you should see around roughly less than 50 data sent to process. 55 has come. Oh good, 55 has come. uh let me see whether all 55 is going to be processed, because we had blocked sometimes, so some data should have been less there. How 55 comes is a good it's strange to see 55, but let me see it. uh PubSub, where's my BigQuery? Okay, go to my BigQuery. 50 message, I had blocked it. Good one. Let me see it, folks. My understanding was that that data would not have reached basically, uh, but it shows 55. So currently everything is going to be streaming inserts only. So your table size is going to be showing as 0. Now let me just query it. Pressure version, few things. I'll also check it what happens when we block it. So 55 records is there, which is little strange. Then the function of block is not working. Let me see it once more. What I will do is I'll block it. What does that block mean? I will just send only 10 messages. Hit enter. It will definitely say cannot communicate to. Let me see. After those 10 entries, it's going to basically stop or it's going to send it. Wanted to get my understanding also clear. So I was thinking if you have blocked it, it's not going to, or it's going to waiting for it to be allowed, then it's going to send it. Maybe the code is written in that way. Let me see it. If I just allow, what happens? Let me just see it. Let me just allow it now. Oh, okay. Okay. And oh, the code is written in such a way. Okay, I understood. The code is written in such a way that if you don't block, the data is never sent. Once you unblock it, the data is then sent. So, okay, good understanding. So, data is going, the simulator is written in such a fashion. It's going to keep checking, polling. If you are blocking me, I'm not going to generate the data itself. If it's allowed, then only it's going to generate it. Now you should see basically 65 records if things are all fine. So 65, you query it, you should be able to get 65 records, all in the streaming buffer. All in the streaming buffer. You will not even see a single record in the persisted on the disk. Everything is still in the streaming buffer. When it's going to flush, nobody knows the answer. It's going to be at some point of time, it's going to flush it out. So that's something which I wanted to show you folks, a comprehensive demonstration where we try to cover our IEM stuffs, our networking stuffs, which we learned, trying to put the best practices there. Still room for improvement is the service account, the specific roles which you gave. Look into it and see if you can still further fine tune to BigQuery admin to something lesser, PubSub admin to something lesser. Then it's going to be really a cool demonstration, I would say, covering 1, 2, 3, 4, networking 5, 6 is your cloud IAM. 6 specific GCP components you are using and doing it. So let me stop it here, folks, for any questions. So we have only one slide left on the big data. So next Saturday when we finish it, we'll discuss about data catalog and we'll have a quiz and we should finish our AI components on Saturday and our stack driver related stuff, DevOps related stuff on Sunday. So let me stop it here, folks, for any questions. Any questions, doubts? Any questions, folks? So was the demo useful, folks? Just wanted to show you the comprehensive one. So, and I never did the private IP demo in the class actually, because these days you will have more questions, the new concepts. So I thought let me show you that also. Yeah. Okay. So thank you, Vivek and Mangesh. So if the demo was helpful, happy, very happy. Okay, just wanted to inform that that I have. Okay, good. Congrats, Vivek. So for your network engineering certification. So good. So was it 50 questions or 60 questions? I heard in one of the LinkedIn somebody mentioned security engineer or something is revamped. It's 60 questions. I'm also not sure whether the new professional cloud architect is going to have 60 questions. Not sure. So if it's 50, meaning Mostly it's the still the older one, so still needs to be revamped. Security engineer is revamped is what I feel. Somebody mentioned in the LinkedIn. Maybe the same applies to cloud architect also. Let's wait and watch if someone posts any comments on it. Any questions, folks? We have around uh, when when you started the network engineer, then I have started learning. Okay, thank you. Um, happy Vivek.
Mahesh, actually, just I thought that networking was one of the toughest things, but after your demo,
Hmm,
I got some
hmm.
more uh, thought that yeah, I can do it.
Good, good,
Uh,
good, good. Same was the case. Same was the case with me. So I also have was feeling very difficult with networking, but my real projects gave me those experience actually. So good.
so yeah, Saturday night itself. I mean, suddenly I was
Oh, good.
studying.
Congrats, congrats.
I should give it immediately. I booked it exam just 10 minutes before. Uh, I just booked it and then
Good, good, good.
9:50 I booked it and 10 p.m. it was. I have appeared and by
Oh, awesome.
11:15 I finished it.
Oh, it was an instant exam, instant clearing, instant response. Good,
Everything was instant.
good,
2 minutes noodle.
good, good, good. Awesome, man.
Thank
So good.
yeah.
Yeah.
So I thought that I will give it on Saturday. Like I was having some doubt, some
Mm.
topics, but you canceled the Saturday exam. Sorry,
Ah, ah,
Saturday
ah,
class. Then I thought, okay,
ah.
let me find it my at my own, and I reworked on this topic again whole Friday morning, and Saturday night
Mm.
immediately I gave it, and it was wonderful.
Awesome, awesome, man. Awesome. Good.
Thank you. My next target is security engineer. Hopefully, let's see when
Yeah,
it will be done.
that's a right. That's how I also did it. So that approach is a good one. So for security engineer, you need to have exposure on network, and you should also have exposure on all the GSP products. That's going to be a good approach. Uh,
Mm,
all the best. So
I
you should
found
be able to definitely do that. Yeah.
I found VPN interconnects are quite elaborate. Whatever we study, that is not enough. It's too exhaustive. Means VLAN attachments, how to achieve HA. That is really confusing.
Mm.
Uh,
Uh,
yeah. But
so for the
I
cloud
think,
architect, yeah, for the network engineer, you need that more those things exposure. Yeah.
but I think the training helped me a lot. I was whatever I have learned in 5 months, and your training. Well, not 6 months. Your training is just 2 months. I learned everything in just 2 or 3 months. Thank you once again. Thank you.
You're welcome. You're welcome. Right. Good. All right, folks, I don't see any questions in the chat, so we'll stop it for today. And sincere apologies for not taking the classes. I had a conflict there, so and thanks that many of you sent a message. Thanks for that. So we'll stop it today. Resume back on next Saturday and look into our AI capabilities and all. All right. Have a great and a safe week ahead, folks. So see you on next Saturday. Thank you. Bye.
This conference will now be recorded.